Hello everyone, good evening. This is Shambhavi, your physics master teacher. Welcome to VEDANTU Karnataka. How are you all? So it's my voice and video. Hope it is audible and visible. Please let me know in the comment. Let me also check here. Hello Sumit, how are you? Okay, thanks for your response, Sumit. A very good evening to everyone. Yes. So, in today's session, we will be starting up with second PUC or class 12th topic, that is electric charges and field. Okay, so today we'll be mainly focusing on the basic properties of charge, Coulomb's law, what is superposition principle, and then how do we define electric field, how to connect between force and field. All those things we'll discuss, and followed by some MCQs as well. Okay, so that will be the plan for today. Yes. Okay, Sumit. Okay, you're currently in first PUC. Oh, okay. Preparing well is good. Okay. Yeah. So simultaneously, we will be doing one chapter from first year and one chapter from second year. Okay. So I'll be focusing on both first year and second year topics. So once one chapter is completed here, we'll move on to the other chapter in, if now I'm doing with second PU, next chapter I'll take from first PU. Okay. So like that I have planned. Okay. So now, as I said, today's topics to be discussed will be electric charge, Coulomb's law, principle of superposition, and electric field. Let us stick to the very basic concepts from this chapter. And once some sufficient information we know about all these basic properties, then we can slowly go for some higher level concepts, as well as some little difficult of MCQs also we will take up. Okay. Hope that will be fine. Okay, I think yes. Okay. So in electric charges and fields, and there's one more chapter called as potential and capacitance. Okay, so togetherly we combine it as a electrostatics. So what do you mean by electrostatics? So the name itself is partially suggesting us something related to electricity and something related to statics. Statics here means rest. That means here we will be talking about the charges which are at rest. Okay, so the properties, the phenomena that are associated with the charges at rest. Okay, so electro means something to do with the electric fields or potentials, electric forces. Okay, and statics refers to the rest concept. That means the charges can be at rest and charges may be moving. So we can broadly classify into two different separate branch in physics. Okay, so when the charge is at rest, whatever we study, we deal under electrostatics. If the charge starts to move, okay, so many other phenomena will arise. If I just had to give you an idea, if the charge is at rest, we just get electric field. So in Bharathanamge, we get only electric field. If the charge is moving, okay, if the charge is moving, we get electric field as well as magnetic field. Okay, so that is what is the charge in motion, and in fact we call that as electrodynamics, okay, or electromagnetism. So like that we study. Okay, charges are at rest, only electric properties. If at all the charge start to move, you get magnetic field. So those phenomena we study later. maybe like your third chapter and fourth chapter. Okay, and also the charge moving charges are nothing but a current that is going to give you current. So all those things we learn later. So in this entire chapter, we are not talking about anything like current or magnetic field. We are just sticking ourselves to the charges which are purely at rest and associated forces, fields, and potential. So that will be under electrostatics. Okay. Yes, hope you're all following. So here and there, please communicate in the chat box so that I will get to know that you're following and you are interested in this session. Okay. Yeah. And okay, fine. So next is, what is a charge? How can we define charge? What exactly is a charge? So basically, it's a fundamental property associated with the matter, we can say. So it's just like mass. Whenever I take some particle, by default, it is associated with certain mass, right? So it's so fundamental that it attained its mass. In the same way, this charge is a property which is, a fundamental property which is associated with the matter, and because of which it can able to produce electrical and magnetic effects. Okay, charge is the main reason from which we are getting our electrical and magnetic effects. Okay, so what is how do you define an electric charge, or what exactly is a charge? So it's like, it is a property, fundamental property, inherent property. Okay, so any particle you take, definitely it will have certain mass, right? You take the smallest particle, you take heavier objects, definitely they are associated with mass. So they are all like some fundamental, inherent property. The same way, charge is also one of the inherent property because of which these particles can able to produce electrical and magnetic effect. So as I said, electrical effect we get when the charges are at rest. So magnetic effect based on the charge should be in motion. Then only we get magnetic effects. Okay. So the next thing is, whenever we come across certain new, physical quantity, what do we do in physics? We certainly try to define its SI unit, right? So what is the SI unit of charge? That is Coulomb. Okay, Coulomb is the SI unit of charge. Capital C is the notation. If you are writing with the full name, you had to use small c, okay, because it's again a name of a scientist. Okay, so Coulomb is the yes, Sumit. Very good. I think you have already attempted the dimension of charge, right? So because we know current is a fundamental quantity which we just have discussed in the last week class, correct? So current, how do we write? That is rate of flow of charge, Q by T anta baritivi. Okay, usually charge notation, no, small q or capital Q taguntivi. That's up to you. You can write capital Q, you can write small q, you can write Q naught, whatever you want. So usual notation is Q. So current is Q by T. From here, how can we write charge? Charge is current into time. So ಈಗ dimension ಬರೆದ್ರೆ, the dimension of charge will be equal to, A into T. I can write down and I can say M0 L0. Okay, we'll put M0 L0 first. There is no dependency on mass. Length is also L0. Current is a fundamental quantity. Its dimensional notation is A. You can write down I. I have no problem with that. So M0, L0, A or I, and T raised to 1. Okay. So the dimension formula is M0, L0, A, T. Okay. So the dimensional notation of current is A or I. That's your choice. Few books have mentioned it as A. Maybe you find certain books where they had written it as I. So with the square bracket, if I is there, it is current. Okay. So this is about basic dimension and SI unit of charge. Moving ahead. So I think you all know, because you have been studying, the basics of charges from your 4th or 5th or maybe like 6th standard and all. So you may know that there are two types of charge. One is positive charge, other is the negative charge, correct? ಸೊ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಮತ್ತೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಅಂತ ಎರಡು ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಮಾಡ್ತೀವಿ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ಹೌ ದೇ ಇಂಟ್ರಾಕ್ಟ್. Okay, so when during the earlier time when they were doing some experiment, they found out that certain types of charges, they attract each other. So, sometimes they repel each other. Depending on that, they came to know that, okay, there are two types of charges. One is positive charge, one is negative charge. So positive charge andre yavadu? One, I can say like the charge on the proton, right? The charge on the proton. Negative charge andre yavadu? The charge on electron. These are all convention we have defined. Okay, the charge on the electron, we call it as negative charge. There is nothing like, something written as plus minus on electron and proton. No, nothing as such. These are all the widely accepted conventions. Okay, we will follow one standard way of representation so that wherever we go, we don't have any confusion in discussing all these things. Okay, so charge on electron is going to be negative in nature. So now positive charge ge one proton anta helbodu, innondu if there is some body is there, it has lost some of electron, lost, or I can say like deficiency of electrons. Okay, deficiency of electron. So that is also going to give you positive charge. So basically, how can we classify? We can say like positive charge and negative charge. Okay, so where do we get negative charge? The charge on the electron is representing the negative charge. Where are the positive charge? So positive charge on the protons, but in our daily, the topics, whatever we discuss, like current agirli, electricity agirli, all these field, force, ions, whatever we discuss, no? So most of the time, the protons are not involving in any movements, okay? But these electrons are going to be moving, distributing. So most of our convention is in terms of electron. Okay, we say deficiency of electrons is going to give us positive charge. If excess electrons are there, that is going to give us negative charge. If you take a neutral body, if you add some electron to it, it takes negative charge. If you remove some electrons from it, it takes positive charge. Okay, so that is one more basic concept with this. Yes, Sunita, hello, good evening. Hope you are done with your today's college. How's it going? Yes, Sumit. Okay. So, if I say I take an atom. So atom ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ? ಸೊ ಒಂದು ಪ್ರೋಟಾನ್ಸ್ ಇರುತ್ತೆ ಇದ್ರೊಳಗಡೆ, ಇನ್ನೊಂದು ನ್ಯೂಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. Okay, the other one is electron. So protons and neutrons togetherly going to give you nucleus. Correct? So ಏನಾಗಿರುತ್ತೆ? If I say there is an atom, okay, so protons ಮತ್ತೆ neutrons ಇರುತ್ತೆ. Neutrons are basically neutral in nature, so ಅದರ charge 0 ಇರುತ್ತೆ. So whereas protons are positively charged, electrons are negatively charged. So ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ? Equal number of positive and negative charge ಇರುತ್ತೆ. Okay, equal number of positive and negative charge. Okay, so equal number of positive ಮತ್ತೆ negative charge ಇರುತ್ತೆ, so that atom as a whole will be neutral. Okay, so now if I want to make an atom a positive or negatively charged body, what I should do? Either I should add some electron or I have to remove some electron. Then only the body attains some charges. Okay, but illenagirutte, as these protons are inside the nucleus, it is not easy to add some protons or remove some protons. They are tightly bound due to their nuclear forces. Okay, so ನೀವು protons ಎಲ್ಲ involve ಮಾಡಬೇಕು ಅಂದ್ರೆ you had to go for some nuclear reactions which are not so easy, which are not so feasible, and which are some sense they are not even as simple chemical reactions. But addition of electron, removing of electrons are very easy. They are just some normal chemical reactions, we can say. Okay, so in all our discussion, protons na ignore madbidi, because in they it is difficult to cause protons to move because they are inside the nucleus, and by default the nucleus are heavy when compared to electrons, so it is not easy to make them to move. Okay, so it is only possible to add electrons or remove electrons to charge a body. Okay, is that clear? Yes. Any doubts, please ask in chat box. Okay, hope instead of discussing something else, you can discuss about the chapter, the topics, and your doubts in the chapters. Okay, yes. So next is properties of charge. So basically charge is a scalar quantity. Okay, they are scalar quantity, they only have magnitude and they do not have any direction, and they are additive in nature. Like if I want to find out the total charge of any system, what I should do, I should add them algebraically. Okay, like plus charges are there, negative charges are there, so you have to add them algebraically. That means I have to add along with their sign. Okay, they being scalar and they are additive in nature. Total charge find out madbekandre add madbeku. It is not that multiplying or dividing or something like that. So charges are additive in nature. The next important concept is charge is conserved. Okay, so what do you mean by conservation of charge? In an isolated system, the total charge remains constant whatever change takes place in that in that system. Okay, the total charge remains constant. So conserved andre constant anta artha. Okay, so if there is an isolated system, like it is entirely separated from the surroundings kind of a thing, so there might be two bodies inside that isolated system, they can exchange their charges. Okay, they can exchange their charges, but the total charge of the system remains constant. Q total remains constant for an isolated system. Okay, charge conservation is always valid. So you go for any reactions, it may be chemical reaction, nuclear reaction, you check with any reaction, still now we have found the charge conservation is valid. Okay, so ನೀವು ರಿಯಾಕ್ಷನ್ಸ್ ಬರೆದ್ರೆ ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡ್ತಿರ್ತೀರಲ್ವಾ, ಈ ಸೈಡ್ ಅಲ್ಲಿ ಇಷ್ಟ ಅಯಾನ್ಸ್ ಇದೆ, ಈ ಸೈಡ್ ಅಲ್ಲಿ LHS ಅಲ್ಲಿ ಇಷ್ಟಿದೆ, RHS ಅಲ್ಲಿ ಇಷ್ಟಿದೆ, you will try to balance the ions and the molecules, correct? So the same way you can cross check with the the total positive charge on one side, the total negative charge on the other side, that will also be always balanced. So charge is conserved. Okay, so that is another basic property of the charge. Okay, so next is charge is quantized. So this is the very important property of the charge, that is quantized. So what do you mean by quantized? So quantized andre discrete values irutte anta, ella continuous value accept madalla, so discrete set of values irutte anta artha. So adanna illi statement alli heng bardidare, charge on any body always exists in integral multiples of a fundamental unit of electric charge. Andre heng baritira, the charge on any body, let us say some Q is there, will be always an integral multiple of the basic charge. So illi this E is the fundamental unit of charge. Okay, and this N can only take the integers like 1, 2, 3, so on. It cannot take values like 1.1, 2.1, 2.3, 5.4. No, fractional values are not allowed. Only the integral multiple of the fundamental unit of electric charge. So ಇಲ್ಲಿ fundamental unit of electric charge na ಯಾವ್ದಂತ define ಮಾಡಿದೀವಿ. So the charge on the electron, charge on electron we take as the fundamental unit of charge, and adra value ಎಷ್ಟಿದೆ 1.6 into 10 power minus 19 Coulomb ide. I think you know this value. Yes or no? Yeah, hope you are following. If you are there, kindly respond in the chat box. Yeah. Okay, so what is charge quantization? The total charge on any system is always, or any body is always going to be integral multiple of the basic charge or fundamental unit of charge. That is the charge on an electron is chosen as the fundamental unit of electric charge. So ಬೇರೆ ಯಾವುದೇ ಒಂದು charge ಬಾಡಿಯಲ್ಲಿ ನೀವು ನೋಡಿದ್ರೆ it is always an integral multiple ಆಗಿರುತ್ತೆ. So you never find like half e, 3/2e, 7/2e ಆ ಥರ ಇರಲ್ಲ. Okay, it is always like 1e, 2e, 10e, 100e, something like that. Okay, so that is the property of charge is quantized. Hope it is clear. Yes, any doubts? Kindly let me know. So the next is charge is relativistically invariant. So idu one important property. So I had given it to you. Apart from this, you can mention so many other trivial properties which I have not given here. But this is another important property, that is charge is relativistically invariant. Andre enartha, the value of the charge is independent of the frame of reference. So frame of reference andre, it is, in other words, we can say the value of the charge do not change with the speed of the particle. So this is very, very important, because now mass tagondre athwa length, time, mass, length, time, which are fundamental quantities, right? So adella enagirutte, they are dependent on frame of reference. So when you go for relativity andre enagirutte, the speed of the particle will be tending to be speed of light ಆಗಿರುತ್ತೆ. Okay, so andre high speed particles alli, okay, or frame of reference in a velocity tumba ಜಾಸ್ತಿ ಇದ್ದಾಗ, in our normal classical physics we don't see all these relativistic variation. When the speed of the particle is tending to see, ಏನು observe ಮಾಡ್ತೀವಿ ಅಲ್ಲಿ, the value of the charge remains constant. It is relativistically invariant. Okay, vary ಆಗಲ್ಲ. ಅದೇ ಮಾಸ್ ಏನಾಗತ್ತೆ, ಮಾಸ್ ಚೇಂಜ್ ಆಗತ್ತೆ, ಲೆಂತ್ ಚೇಂಜ್ ಆಗತ್ತೆ, time change agate. You may heard the terms like time dilation, length contraction, mass change, relativistic mass, correct? So which is like a frame of reference dependent. So what is the velocity of the frame of reference? Depending on that, mass, time, length ella change agate, but charge is relativistically invariant. Okay, so adara value change agalla. Is that clear? Any other doubts? Hope we can go ahead, and please mark your attendance. Okay, you can mark your attendance so that we will get to know how many of you are attending, how many of you are actively participating. Please do mark your attendance. Okay, yeah. So moving ahead to the concept called as method of charging a body. Okay, how to charge a body? So there are three basic methods. One is charging by friction. Okay, so illi charging by friction andre two suitable material na navu rub ಮಾಡ್ತೀವಿ. Okay, yeah. So when a material ಯಾವ್ದು ಆಗಲ್ಲ, ಇಲ್ಲಿ you can see the page. Okay, so when two suitable substances are rubbed with each other, so one has a tendency to lose electron, the other has a tendency to gain electron. Okay, so allenagutte, electron will be transferred from one body to the other body agutte. So the body which loses the electron will attain positive charge, the body which gains the electron will attain negative charge. Okay, so ಈಗ ಯಾವ ಬಾಡೀಸ್ ನ ತಗೊಂಡ್ರೆ ಸಮ್ ಎಕ್ಸಾಂಪಲ್ ಇದೆ. ಸೊ ಇಲ್ಲಿ ಒಂದು ಸೀರೀಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ ನಿಮ್ಗೆ, ಗ್ಲಾಸ್ ರಾಡ್ ಮತ್ತೆ ಸಿಲ್ಕ್ ಕ್ಲಾತ್. ಓಕೆ, ಗ್ಲಾಸ್ ರಾಡ್ ನ ಸಿಲ್ಕ್ ಕ್ಲಾತ್ ಜೊತೆ ರಬ್ ಮಾಡಿದ್ರೆ ಸೊ ಏನಾಗತ್ತೆ, ದೇ ವಿಲ್ ಬಿ ಚಾರ್ಜ್. ಸೊ ಗ್ಲಾಸ್ ರಾಡ್ ವಿಲ್ ಅಟೈನ್ positive charge, whereas silk cloth will gain electrons. Okay, so let me just write it down. So ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಂದ್ರೆ electrons are lost. Okay, ಏನಾಗಿರುತ್ತೆ electrons are lost. ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ electrons are gained. Okay, so similarly woolen cloth na ನೀವು ರಬ್ಬರ್ ಜೊತೆಗೋ ಪ್ಲಾಸ್ಟಿಕ್ ಆಬ್ಜೆಕ್ಟ್ ಜೊತೆಗೋ ರಬ್ ಮಾಡಿದ್ರೆ again you see one will be charged with positive, that means they are losing the electron, and the other will be negatively charged, that means they are gaining the electron. Okay, and similarly dry hair na comb madidre, you may have observed this, correct? So dry hair na comb, plastic comb tagondo when you comb it, okay, so after some time you may feel like your hairs are getting attracted, right? So it's because one is positively charged, one is negatively charged agatte, so that they start attracting each other. Next, to cat skin with ebonite rod. So this is another example. Okay, so usually glass rod ಮತ್ತೆ silk cloth ಇಂದು ಕೇಳಬಹುದು MCQ ಅಲ್ಲಿ. So ಯಾವುದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಟೈನ್ ಮಾಡುತ್ತೆ, ಯಾವುದು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಅಟೈನ್ ಮಾಡುತ್ತೆ. Okay, so just remember these 4-5 examples. ಆಯ್ತಾ? Yeah, any doubts? Okay. Okay, so next is the second method is, the one method is charging by friction. That is by friction anta yaake heltivi, here we are rubbing one surface on the other surface. Okay, because of the friction only one body will lose electrons, they will come out, the other will gain electron. So that's why we call it as charging by friction. So second is charging by conduction or flow. So it is a very simple one. Okay, so let us say that we have a charged body. Okay, so charged body ತಗೊಂಡ್ರೆ ಏನ್ ಮಾಡೋಣ, ಒಂದು ಕಂಡಕ್ಟಿಂಗ್ ವೈರ್ ತಗೊಳ್ಳೋಣ. Okay, and now let us say there is an uncharged body. Okay, ಅದಕ್ಕೆ ಕನೆಕ್ಟ್ ಮಾಡೋಣ. So ಏನಾಗುತ್ತೆ, the charges will flow, correct? Or what I'll do is I'll just make a negatively charged body, because that becomes easy for me to represent. In a second. Yeah. So let us say there's a negatively charged body. So negatively charged body andre enagirutte, excess electrons irutte, and there is a neutral body. So next ಏನು ಮಾಡ್ತೀವಿ, we are connecting them with a conducting wire. Okay, so conducting wire ಯಾವ್ದಾದ್ರು ಮೆಟಲ್ ವೈರ್ ತಗೊಂಡು ಕನೆಕ್ಟ್ ಮಾಡಿ, ಆಗ ಏನಾಗುತ್ತೆ, this will attain some charge. Okay, so initially ಇದರಲ್ಲಿ ಒಂದು 10 ಕೂಲೂಮ್ ಇದ್ರೆ, ಓಕೆ, ಏನಾಗುತ್ತೆ ನೆಕ್ಸ್ಟ್ ಎರಡು ಚಾರ್ಜ್ ನ ಶೇರ್ ಮಾಡುತ್ತೆ, 5 ಕೂಲೂಮ್ ತರ, provided they should be identical size. Okay, so the conductors, if they are of identical in nature, then they share equally. Illa andre it depends on their the radius of the conductor. Okay, so adana ನೀವು potential concept ಅಲ್ಲಿ ಅರ್ಥ ಮಾಡ್ಕೊಂತೀರಾ. So ಯಾವ್ದ್ರಲ್ಲಿ ಎಷ್ಟು ಚಾರ್ಜ್ ಉಳಿಯುತ್ತೆ, okay, how it is related to radius, how it is related to the material, ಅದೆಲ್ಲ ನೀವು potential ಅಲ್ಲಿ ನೋಡ್ತೀರಾ. So time being you can understand that, okay, they will share their charges. Okay, so the charge will flow from one to other. Is that clear? Hope it is clear. Okay, any doubts you can ask. So ಏನಾಗಿರುತ್ತೆ, here the two bodies are actually in contact. Okay, the two bodies are in contact. Okay, next one method is that is charging by induction. So charging by induction ಅಂದ್ರೆ ಏನು, ಇಲ್ಲಿ they are not in contact with each other. Again illu two bodies ತಗೋತೀವಿ, it can be a conductor or an insulator. Okay, two bodies ತಗೋತೀವಿ, where one is a charged body, the other is the uncharged or neutral body. So ಆ neutral body ಏನ್ ಮಾಡ್ತೀವಿ, we bring it near the charged body. Okay, now because of the the charge on the charged body, it will try to repel the like charges and it will try to attract the opposite charge. Okay, so adike enagate, one side becomes negative, other side becomes positive, and this phenomena we call it as electrostatic induction. So induction andre enu, induce ಮಾಡ್ತಾ ಇರೋದು. Okay, so ಒಂದು charged body ಇದೆ, ಇನ್ನೊಂದು uncharged body ಇದೆ. So we are not bringing them in contact like in the case of second case. ಆ ತರ ಮಾಡ್ತಾ ಇಲ್ಲ ಇಲ್ಲಿ. We are just bringing them close to each other. Okay, but because of the property of repelling the like charges, so second body one side ಅಲ್ಲಿ negative charge ಆದ್ರೆ ಇನ್ನೊಂದು side ಅಲ್ಲಿ positive charge ಆಗಿರುತ್ತೆ. So there is a diagrammatic representation. Hope that will give you the better idea. So if you are there, please mark your attendance as well. Yes, Rohini, you can mark your attendance. Okay. So illenagide, here we have a charged ebonite rod. Okay, so this is a charged body initially. Okay, so adanna ಏನು ಮಾಡಿದ್ವಿ, we have taken it to close to the metal sphere which was initially uncharged, but ಇಲ್ಲಿ negative charge ಇರೋದ್ರಿಂದ ಈ ಸರ್ಫೇಸ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಕ್ಯುಮುಲೇಟ್ ಆಗುತ್ತೆ. ಸೊ ಇಟ್ ಹ್ಯಾಸ್ ಅ ಟೆಂಡೆನ್ಸಿ ಟು ರಿಪೆಲ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ಆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಲ್ಲ ಮೂವ್ ಆಗಿ ಇಲ್ಲಿ ಅಕ್ಯುಮುಲೇಟ್ ಆಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ ಈ ಕಡೆ ಎಲೆಕ್ಟ್ರಾನ್ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಆಗುತ್ತೆ, ಈ ಕಡೆ ಎಕ್ಸೆಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇರೋದ್ರಿಂದ ಸೊ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಇರೋ ಚಾರ್ಜ್ ರೀಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಆಗಿರೋದು ಅಷ್ಟೇ ಇಲ್ಲಿ. ಓಕೆ, ಸೊ ವಿ ಆರ್ ನಾಟ್ ಬ್ರಿಂಗಿಂಗ್ ದಮ್ ಇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್. ಇಲ್ಲಿ ಎಬೋನೈಟ್ ರಾಡ್ ನ ಈ ಮೆಟಲ್ ಸ್ಪಿಯರ್ ಗೆ ನಾನು ಟಚ್ ಮಾಡಿಸ್ತಾ ಇಲ್ಲ, ಅಥವಾ ಯಾವ್ದೋ ಒಂದು ಕಂಡಕ್ಟಿಂಗ್ ವೈರ್ ತಗೊಂಡು ಕನೆಕ್ಟ್ ಮಾಡ್ತಾ ಇಲ್ಲ. ಬಟ್ ಏನಾಗಿದೆ, ಬಿಕಾಸ್ ಆಫ್ ದಿ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ದಿ ಚಾರ್ಜ್, ಸೊ ಇಟ್ ಈಸ್ ನೆಗೆಟಿವ್ಲಿ ಚಾರ್ಜ್. It has a tendency to repel these negative charge. On a consequence, you are getting a positive charge on the other side. So ಈಗ immediately ಏನ್ ಮಾಡಬೇಕು, ಈ ಸೈಡ್ ಅನ್ನ ಗ್ರೌಂಡ್ ಮಾಡಬೇಕು. ಓಕೆ, ಇಮಿಡಿಯೇಟ್ಲಿ ಗ್ರೌಂಡ್ ಮಾಡಬೇಕು. ಸೊ ಗ್ರೌಂಡ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಎಕ್ಸೆಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ರೆ ಗ್ರೌಂಡಿಗೆ ಹೊರಟೋಗುತ್ತೆ, ಅಥವಾ ಇಫ್ ಎಕ್ಸೆಸ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದ್ರೆ ಸಮ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ವಿಲ್ ಫ್ಲೋ ಫ್ರಮ್ ಗ್ರೌಂಡ್ ಆಗುತ್ತೆ. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಇಲ್ಲಿ ಎಕ್ಸೆಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇತ್ತು. ಓಕೆ, ಸೊ ಅದೆಲ್ಲ ಗ್ರೌಂಡಿಗೆ ಹೋಗಿದೆ ಅಂಡ್ ಇಮಿಡಿಯೇಟ್ಲಿ ಆ ಗ್ರೌಂಡ್ ಕನೆಕ್ಷನ್ ನ ರಿಮೂವ್ ಮಾಡಬೇಕು, ಸೋ ದಟ್ ಇಲ್ಲಿ ಉಳಿದಿರುವ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಏನಿದೆ ಅದೆಲ್ಲ ಯೂನಿಫಾರ್ಮ್ ಆಗಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ದಿ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಇಂಡಕ್ಷನ್, ಚಾರ್ಜ್ ಬೈ ಇಂಡಕ್ಷನ್. ಓಕೆ, ಚಾರ್ಜಿಂಗ್ ಬೈ ಇಂಡಕ್ಷನ್. ಸೊ ಎನಿ ಡೌಟ್? ಸೊ ಏನ್ ಮಾಡ್ತೀವಿ, ಒಂದು ಚಾರ್ಜ್ ಬಾಡಿ ಇನ್ನೊಂದು ಅನ್ಚಾರ್ಜ್ ಬಾಡಿ, ವಿ ಬ್ರಿಂಗ್ ದೆಮ್ ಕ್ಲೋಸ್ ಟು ಈಚ್ ಅದರ್ ಸೋ ದಟ್ an opposite charge has been induced. ಇದು ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು. ಇಲ್ಲಿ ನಮ್ಗೆ ನೆಗೆಟಿವ್ಲಿ ಚಾರ್ಜ್ ಬಾಡಿ ಇದ್ದಿದ್ದು ಇಂಡ್ಯೂಸ್ ಆಗಿರೋ ಚಾರ್ಜ್ ಆಪೋಸಿಟ್ಲಿ ಚಾರ್ಜ್ ನ ಇಂಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಒನ್ ಅನದರ್ ಮೆಥಡ್ ಆಫ್ ಚಾರ್ಜಿಂಗ್ ಎ ಬಾಡಿ. ಇಲ್ಲಿ ಒಂದು ಫಾರ್ಮುಲಾ ಇದೆ, ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ಸಮ್ ಟೈಮ್ಸ್ ದೇ ಮೇ ಆಸ್, ಅಂಡ್ ಇದು ನಿಮ್ಗೆ ಕೆಪಾಸಿಟರ್ಸ್ ಅಲ್ಲೂ ಬರಬಹುದು. ಒನ್ ಕ್ವೆಶನ್ಸ್ ಅಲ್ಲಿ ಕೇಳ್ಬೋದು ಇಂಡ್ಯೂಸ್ ಚಾರ್ಜ್ ಬಗ್ಗೆ. ಸೊ ದ ಅಮೌಂಟ್ ಆಫ್ ಇಂಡ್ಯೂಸ್ ಚಾರ್ಜ್ ಇಸ್ ಗಿವನ್ ಬೈ Q dash is equals to minus Q into 1 minus 1 by K. Okay, ಇಲ್ಲಿ Q ಅಂದ್ರೆ the charge on the initially charged conductor. Q dash ಅಂದ್ರೆ induced charge. ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಸೈನ್ ಯಾಕಿದೆ, ಬಿಕಾಸ್ ಚಾರ್ಜಿಂಗ್ ಬೈ ಇಂಡಕ್ಷನ್ ಅಲ್ಲಿ ಯಾವಾಗ್ಲೂ ಆಪೋಸಿಟ್ ಚಾರ್ಜ್ ಜನರೇಟ್ ಆಗಿರೋದು. ಓಕೆ, ಪಾಸಿಟಿವ್ ಕಂಡಕ್ಟರ್ ಇದ್ರೆ ನಿಮ್ಗೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ, ನೆಗೆಟಿವ್ ಕಂಡಕ್ಟರ್ ಇದ್ರೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ನಿಮ್ಗೆ ನೆಗೆಟಿವ್ ಸೈನ್ ಬರುತ್ತೆ. And this K is something called as dielectric constant, okay, which you will learn in a little while when we learn in detail with Coulomb's law. Okay, so what is K? Dielectric constant of this uncharged conductor. Okay, ಇಲ್ಲಿ ಏನು uncharged body ಇರುತ್ತಲ್ಲ initially, ಅದರ dielectric constant ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ ಎಷ್ಟು ಚಾರ್ಜ್ ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ ಅನ್ನೋದು. Okay, is that clear? Hope we can go ahead. Yes, if you're following, just give me a response in the chat box. And also you can like this session if you're following it. And if you're new to the channel, please do subscribe to our channel. Hope you're all watching it. Any doubts, please feel free to ask in the chat box. Okay? Yeah. So the next concept is gold leaf electroscope. So gold leaf electroscope andre enu? So it is a simple apparatus to check whether the body is charged or not. If there is any excess electric charge is there on the body, that can be detected using a gold leaf electroscope. Okay, so illi gold leaf electroscope ಅಲ್ಲಿ ಏನೇನ್ ಪಾರ್ಟ್ಸ್ ಇರುತ್ತೆ ಅಂಡ್ ಹೌ ಇಟ್ ವರ್ಕ್ಸ್. ಇಟ್ಸ್ ಅ ವೆರಿ ಸಿಂಪಲ್ apparatus, ಈಸಿಯಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬಹುದು. ಸೊ ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಎರಡು ತಿನ್ ಗೋಲ್ಡ್ ಲೀಫ್ ಕೊಟ್ಟಿರ್ತಾರೆ, ತಿನ್ ಫಾಯಿಲ್ ತರ ಇಮ್ಯಾಜಿನ್ ಮಾಡಿ, ಎರಡು ತಿನ್ ಗೋಲ್ಡ್ ಫಾಯಿಲ್ ಇರುತ್ತೆ. ಓಕೆ, ಸೊ ಗೋಲ್ಡನ್ ಯಾಕೆ ತಗೋತಾರೆ ಅಂದ್ರೆ ಅದರ ಕಂಡಕ್ಟಿವಿಟಿ ವೆರಿ ಹೈ ಇರುತ್ತೆ. ಸೊ ವಿ ಆರ್ ಚೂಸಿಂಗ್ ಗೋಲ್ಡ್. ಅದನ್ನ ಏನ್ ಮಾಡಿರ್ತಾರೆ, ಸಮ್ ಕಂಡಕ್ಟಿಂಗ್ ರಾಡ್, ಇಲ್ಲಿ ಏನಿದೆ ಬ್ರಾಸ್ ರಾಡ್ ನ ಕನೆಕ್ಟ್ ಮಾಡಿ ಇಲ್ಲಿ ಒಂದು ಬ್ರಾಸ್ ಡಿಸ್ಕ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಓಕೆ, ಸೊ ಬ್ರಾಸ್ ಇಸ್ ಎ ಕಂಡಕ್ಟರ್. ಸೊ ಇಲ್ಲಿ ಎಕ್ಸ್ಟರ್ನಲ್ ಸಪೋರ್ಟ್ ಗೆ ಇನ್ಸುಲೇಟಿಂಗ್ ಪ್ಲಗ್ ಯೂಸ್ ಮಾಡಿರ್ತಾರೆ. ಅಂಡ್ ದಿಸ್ ಎಂಟೈರ್ ಸೆಟಪ್ ಇಸ್ ಪ್ರೊವೈಡೆಡ್ ಇನ್ ದಿ ಗ್ಲಾಸ್ ಬಾಟಲ್. ಓಕೆ, ಸೊ ಒಂದು ಇವ್ಯಾಕ್ಯೂಟೆಡ್ ಗ್ಲಾಸ್ ಚೇಂಬರ್ ಅಲ್ಲಿ ಇಟ್ಟಿರ್ತಾರೆ. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಜಸ್ಟ್ ಟು ಅವಾಯ್ಡ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಇನ್ಫ್ಲೂಯೆನ್ಸ್ ಏನ್ ಮಾಡಿರ್ತಾರೆ, ಒಂದು ಅಲ್ಯೂಮಿನಿಯಂ ಫಾಯಿಲ್ ಹಾಕಿರ್ತಾರೆ, ಸಮ್ ಮೆಟಲ್ ಫಾಯಿಲ್, ಯೂಶಲಿ ಅಲ್ಯೂಮಿನಿಯಂ, ಅಂಡ್ ಅದನ್ನ ಅರ್ತ್ ಮಾಡಿರ್ತಾರೆ ಜಸ್ಟ್ ಟು ಅವಾಯ್ಡ್ ಎನಿ ಎಕ್ಸ್ಟರ್ನಲ್ ಚಾರ್ಜ್ ಇನ್ಫ್ಲೂಯೆನ್ಸ್. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡೋದು, ಇಲ್ಲಿ ಇಫ್ ಯು ಬ್ರಿಂಗ್ ಸಮ್ conducting bodies, okay, I mean charged body, ಯಾವ್ದೋ ಒಂದು ಚಾರ್ಜ್ ಬಾಡಿ, ಪಾಸಿಟಿವ್ ಆಗಿರ್ಲಿ ನೆಗೆಟಿವ್ ಆಗಿರ್ಲಿ, ಸಮ್ ಚಾರ್ಜ್ ಬಾಡಿ ವಿ ಆರ್ ಟೇಕಿಂಗ್ ಅಂಡ್ ಏನ್ ಮಾಡ್ತೀವಿ, ವಿ ಆರ್ ಪ್ಲೇಸಿಂಗ್ ಇಟ್ ಟು ದಿ ಬ್ರಾಸ್ ಡಿಸ್ಕ್. ಓಕೆ, ಅದಕ್ಕೆ ಟಚ್ ಮಾಡಿಸ್ತೀವಿ. ಆಗೇನಾಗತ್ತೆ, ದ ಚಾರ್ಜಸ್ ವಿಲ್ ಗೋ ಫ್ರಮ್ ದಿಸ್ ಕಂಡಕ್ಟಿಂಗ್ ಬಾಡಿ ಟು ದಿಸ್ ಡಿಸ್ಕ್. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಏನಾಗತ್ತೆ, ಆಸ್ ದೇ ಮೂವ್ ಡೌನ್, ಸೊ ಇಲ್ಲಿ ಎರಡು ಗೋಲ್ಡ್ ಫಾಯಿಲ್ ಏನಾಗತ್ತೆ, ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್ ಆಗತ್ತೆ. ಓಕೆ, ಬೋತ್ ದಿ ಫಾಯಿಲ್ಸ್ ಬಿಕಮ್ ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್ ಆಗತ್ತೆ. ಸೊ ವಿ ನೋ ದಟ್ ಲೈಕ್ ಚಾರ್ಜಸ್ ರಿಪೆಲ್ ಈಚ್ ಅದರ್. ಸೊ ಅದಕ್ಕೆ ಏನಾಗತ್ತೆ, ಇನಿಷಿಯಲಿ ಫಾಯಿಲ್ ಒಂದು ಮೇಲೆ ಇನ್ನೊಂದಿದ್ರೆ, ಸೊ ಆಸ್ ದೇ ಬಿಕಮ್ ಲೈಕ್ಲಿ ಚಾರ್ಜ್, ದೇ ಸ್ಟಾರ್ಟ್ ಟು ರಿಪೆಲ್ ಈಚ್ ಅದರ್. ಅಂದ್ರೆ ಏನಾಗತ್ತೆ, ಸಮ್ ಆಂಗಲ್ ವಿಲ್ ಬಿ ಕ್ರಿಯೇಟೆಡ್ ಹಿಯರ್. ಓಕೆ, ಸೊ ಆಂಗಲ್ ಆಫ್ ಡೈವರ್ಜೆನ್ಸ್ ಅಂತೀವಿ. ಓಕೆ, ಸೊ ಏನಾಗಿರುತ್ತೆ, ಆಸ್ ಲೈಕ್ ಚಾರ್ಜಸ್ ರಿಪೆಲ್ ಈಚ್ ಅದರ್. ಸೊ ಯಾವಾಗ ಎರಡು ಗೋಲ್ಡ್ ಫಾಯಿಲ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಆರ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್, ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ವಿಚ್ ಟೈಪ್ ಆಫ್ charged body you are bringing here. Okay, if you are bringing some other type of charged body, let us say some negatively charged body. Okay, so again agate again, yeah, both the foils will be negatively charged agate. Okay, so again they repel each other, some angle of divergence baratte. So more the charges that are accumulated in the body, so angle of divergence enagate ಜಾಸ್ತಿ ಆಗತ್ತೆ. Okay, so more the charge that are accumulated in the electroscope, so angle of divergence ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So the angle of divergence gives a rough amount of charge on the body. ಒಂದು ಐಡಿಯಾ ಕೊಡುತ್ತೆ. Okay, depending on this angle of divergence, you can calculate how much amount of charge was there on the given charged body. Okay, yeah, any doubts? Yes, Sunita and Ramesh. Any doubts? You can ask here. Hope you are following and you have marked your attendance. And if you are following the session, please do like the session. Okay, so we can go ahead, I hope. So what we have learned till now, so it's like, what are charges? Okay, properties of charges, unit, the dimension, very basic properties of charges like quantized, additive, scalar, and then relativistically invariant. Okay, so and also conservation property. Okay, and then how to charge a body. So then we have moved on to charging a body. There are again three methods like friction, conduction and induction. And now how to identify whether the body is charged or not, how to check whether the body is charged or not. So the one method is to use the gold leaf electroscope to find the amount of charges on any body. Okay, hope it is clear. I think we can move ahead. Yeah. So the next is Coulomb's law. Very, very, very important for your board exam, NEET, if you are writing KCT or if you are writing JEE and all. So Coulomb's law is one of the very important concept. So first we'll understand the law and then we'll see how problems can be framed on this. Okay. So what is the statement of Coulomb's law? The electrostatic force of interaction between two static point electric charges is directly proportional to the product of magnitude of the charge and inversely proportional to the square of the distance between them, and the force acts along the line joining the two charges. So in ಹೇಳ್ತಾ ಇದೀವಿ, we are taking two charges, let me say Q1, Q2, okay, and let us imagine the charges are separated by a distance r. So Coulomb's law ಏನು ಹೇಳುತ್ತೆ, the force of interaction, it can be attraction or repulsion depending on whether we have positive charges or positive and negative charge. Like charge ಇದೆಯಾ unlike charge ಇದೆಯಾ ಅನ್ನೋದ್ರ ಮೇಲೆ attract ಆಗುತ್ತಾ repel ಆಗುತ್ತಾ ಅಂತ ಹೇಳ್ಬೋದು. So the magnitude of the force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. That is, F is proportional to Q1 Q2 by R square, or proportionality ಇದ್ದಾಗ equality ಬರಿಬೇಕು ಅಂದ್ರೆ ಏನು, so we had to introduce a constant. So F is equals to K Q1 Q2 by R square ಆಗುತ್ತೆ. Here I am just writing the magnitude. Okay, yeah, the magnitude of the force is directly proportional to the magnitude of the charge and inversely proportional to the square of the distance between them ಅಂತ ಇರೋದು. So ಈ K value ಏನಿಲ್ಲಿ, that is very important. K is equals to 1 by 4 pi epsilon naught in SI system. Okay, so the proportionality constant in Coulomb's law in SI system is 1 by 4 pi epsilon naught, which has a value like 9 into 10 power 9 SI units anta baritini. Okay, but illi epsilon naught andre enu, that is also very important. So let me just add a page here. So enu, here we can say, okay, epsilon naught andre enu, absolute permittivity of free space or vacuum, or you can also say air. Okay, absolute permittivity of air or vacuum. Okay, it has a value like 8.854 into 10 power minus 12 SI units. Okay, so ಈಗ full formula ಬರೆದ್ರೆ ಏನಾಗುತ್ತೆ, F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. So here I am just writing the magnitude of the force between two point charges which are at rest. Okay. Yes, Chetan. Good evening. Hope you are following this session. And please mark your attendance if you have just joined. Okay. So this is how we write down the Coulomb's law. 1 by 4 pi epsilon naught, that's a medium dependent term. So ಯಾವ ಟರ್ಮ್ ಅಲ್ಲಿ ಇದೆ, that is epsilon naught ಅಂದ್ರೇನು, absolute permittivity of air or vacuum ಆಗಿರುತ್ತೆ. Okay, for if in case we have other medium, ಬೇರೆ medium ಇದ್ರೆ ಏನಾಗುತ್ತೆ, for some medium ಈ ಫಾರ್ಮುಲಾ ಹೆಂಗ್ ಚೇಂಜ್ ಆಗುತ್ತೆ, so force in medium will be equal to 1 by 4 pi epsilon m ಆಗುತ್ತೆ. Okay, 1 by 4 pi epsilon m into Q1 Q2 by R square ಆಗುತ್ತೆ, where this epsilon m ಅಂದ್ರೇನು, permittivity of that medium. Okay, of the given medium. Okay, so there is a relation with this epsilon m and epsilon naught. I'll just give it to you here, and in later also we will be having a discussion. So ಏನಾಗಿರುತ್ತೆ, there is something called as dielectric constant. Okay, so let me take it as epsilon r, which is the ratio of epsilon m by epsilon naught. Okay, so idenidu dielectric constant anta karitivi. Okay, dielectric constant. Sometimes idana k anno notation indanu baritare. Okay, epsilon or k. So your choice. Okay, epsilon or is dielectric constant or relative permittivity. So that word also you can use. Relative permittivity. Okay, is that clear? So in baribodaga epsilon m is equals to k time epsilon naught or epsilon naught. Okay, is that clear? So from medium to medium, the value of epsilon r or epsilon m varies. Depending on that, the force between the two charges will also change. So that's what I mean to say here. The Coulomb force is a medium dependent one. Okay, so any doubt? Okay, so I think we can go ahead. If there are no doubts. Okay, so next is Coulomb's law in vector form. I already told you that we are discussing about a force and we know that force is a vector quantity. So finally force in a direction namage gottirbeku. That means nothing but we should know how to write Coulomb's law in the vector notation. Vector notation andre enagirutte direction bardirtira along with the magnitude. So illi one notation ide, just to give you an idea I have taken this. Okay, so ನೀವು already ಯಾವುದೋ ಒಂದು notation ಗೆ ಫಿಕ್ಸ್ ಆಗಿದೆ, you can follow that notation. So but ಪ್ರಾಪರ್ ಆಗಿ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿನೂ ಅದನ್ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಬೇಕು. ಈಗ ಫೋರ್ಸ್ ಆನ್ Q1 ಡ್ಯೂ ಟು Q2 ಅಂದ್ರೆ ಅವರ್ Q1 is here, our Q2 is here. So force on this, that means Q1 is my system now. Force on Q1, ಆಗ Q1 ರಿಪೆಲ್ ಆಗ್ತಿದೆಯಾ ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಿದೆಯೋ ಡ್ಯೂ ಟು ದಿ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ Q2. ಅದರ ನೊಟೇಷನ್ ಏನ್ ತಗೊಂಡಿದ್ದೀನಿ ನಾನು, F12 ಅಂತ ತಗೊಂಡಿದ್ದೀನಿ. ಓಕೆ, ಫೋರ್ಸ್ ಆನ್ 1 ಡ್ಯೂ ಟು ಸೆಕೆಂಡ್ ಚಾರ್ಜ್ will be equal to magnitude ಬರೆಯಕ್ಕೆ ನಿಮ್ಗೆ ಏನು ಡೌಟ್ ಇಲ್ಲ, k q1 q2 by r square. ಇಲ್ಲಿ k ಅಂದ್ರೆ again ಏನಿದು ಅವರ್ 1 by 4 pi epsilon naught. ಓಕೆ, ಸೊ ಯೂಶಲಿ ನಾನು ಎಪ್ಸೈಲನ್ ಆರ್ ನೋಟೇಷನ್ ತಗೊಂತೀನಿ ರಿಲೇಟಿವ್ ಪರ್ಮಿಟಿವಿಟಿಗೆ, ಜಸ್ಟ್ ಟು ಅವಾಯ್ಡ್ ದಿ ಕನ್ಫ್ಯೂಷನ್ ಬಿಟ್ವೀನ್ ದಿಸ್ k, ದಟ್ ಇಸ್ ದಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಫ್ ಕೂಲುಮ್ಸ್ ಲಾ. ಕಾನ್ಸ್ಟೆಂಟ್ ಆಫ್ ಪ್ರೊಪೋರ್ಷನಾಲಿಟಿ ಫ್ರಮ್ ಕೂಲುಮ್ಸ್ ಲಾನು k ಅಂತಾನೆ ಬರೀತಾರೆ ತುಂಬಾ ಬುಕ್ಸ್ ಅಲ್ಲಿ. ಓಕೆ, ಲೇಟರ್ 1 by 4 pi epsilon naught ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾರೆ, ಜಸ್ಟ್ ಟು ಅವಾಯ್ಡ್ ದಿ ಕನ್ಫ್ಯೂಷನ್ ಬಿಟ್ವೀನ್ this constant of proportionality from Coulomb's law and dielectric constant. ನಾನು ಏನು ಮಾಡ್ತೀನಿ, ಯೂಶಲಿ epsilon r notation ಯೂಸ್ ಮಾಡ್ತೀನಿ. Okay, if you are not comfortable with that, you can still write k for dielectric constant. Okay, yeah, magnitude ಏನು ಡೌಟ್ ಇಲ್ಲ, k q1 q2 by r square. So direction ಏನಾಗಿರುತ್ತೆ ಇಲ್ಲಿ, if you assume both are positive charge, ಏನಾಗಿರುತ್ತೆ ರಿಪೆಲ್ ಆಗತ್ತೆ. ಅಂದ್ರೆ Q1 will try to move away from Q2, right? ಸೊ ಈ ಡೈರೆಕ್ಷನ್ ಇರುತ್ತೆ. ರಿಪೆಲ್ ಅಂದ್ರೆ ಇಟ್ ಶುಡ್ ಮೂವ್ ಅವೇ, ಕರೆಕ್ಟ್. ಅಟ್ರಾಕ್ಷನ್ ಅಂದ್ರೆ ಅದು ಕಮ್ಸ್ ಟುವರ್ಡ್ಸ್ ದಿ Q2 ಆಗುತ್ತೆ. ರಿಪೆಲ್ ಅಂದ್ರೆ ಇಟ್ ಮೂವ್ಸ್ ಅವೇ, ಅಂದ್ರೆ ಡೈರೆಕ್ಷನ್ ಏನು ಈ ಕಡೆ. ಓಕೆ, ಸೊ ದಟ್ ಈಸ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್, ಕರೆಕ್ಟ್. ಸೊ ಆ ಯೂನಿಟ್ ವೆಕ್ಟರ್, ಆ ಡೈರೆಕ್ಷನ್ ಯೂನಿಟ್ ವೆಕ್ಟರ್ ನ ಏನ್ ತಗೊಂಡಿದ್ದಾರೆ, R21 ಅಂತ ತಗೊಂಡಿದ್ದಾರೆ. ಓಕೆ, ಸೊ ದ ಡೈರೆಕ್ಷನ್ ಫ್ರಮ್ 2 to 1 ವೆಕ್ಟರ್ ಏನಿದೆ ಅಲ್ಲ, ಸೆಕೆಂಡ್ ಚಾರ್ಜ್ ಇಂದ ಫಸ್ಟ್ ಚಾರ್ಜ್ ಇರೋ ಡೈರೆಕ್ಷನ್ ಯೂನಿಟ್ ವೆಕ್ಟರ್ R21 ಕ್ಯಾಪ್ ಅಂತ ತಗೊಂಡಿದ್ದಾರೆ. ಓಕೆ, ಸೊ R12 ಅಂದ್ರೆ ಏನದು, ದ ವೆಕ್ಟರ್ ವಿಚ್ ಇಸ್ ಡೈರೆಕ್ಟೆಡ್ ಫ್ರಮ್ ಫಸ್ಟ್ ಚಾರ್ಜ್ ಟು ಸೆಕೆಂಡ್ ಚಾರ್ಜ್, ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಇಟ್ ಆಸ್ R21 ವೆಕ್ಟರ್. ಅಂಡ್ ಯೂನಿಟ್ ವೆಕ್ಟರ್ ಅಂದ್ರೇನು, ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಒಂದು ಜಸ್ಟ್ ಇಟ್ ವಿಲ್ ಗಿವ್ ಯು ದಿ ಡೈರೆಕ್ಷನ್ ಅಂತ. ಓಕೆ, ಸೊ ಸೆಕೆಂಡ್ ಕೇಸ್ ಅಲ್ಲಿ ಏನಿದೆ, ದ ಫೋರ್ಸ್ ಆನ್ ಸೆಕೆಂಡ್ ಚಾರ್ಜ್ ದಟ್ ಇಸ್ Q2 ಡ್ಯೂ ಟು Q1, ಫೋರ್ಸ್ ಆನ್ ದ ಚಾರ್ಜ್ ಟು ಡ್ಯೂ ಟು Q1. ಓಕೆ, ಅಗೈನ್ ಅದು ಪಾಸಿಟಿವ್ ಇದ್ರೆ ಏನಾಗುತ್ತೆ, it will also repel in this direction, correct. So ಏನಾಗಿರುತ್ತೆ, this will also repel in this direction, yes or no? Yeah, if both are like charges, they repel each other, they move away like this, correct. So Q2 will try to move away from Q1, or the force on Q2 will try to push away the Q2. It is not trying to pull towards the Q1, it is trying to push away Q2. Okay, so ಅದರ ಡೈರೆಕ್ಷನ್ ಏನಿರುತ್ತೆ, so the direction is this way, correct. So from Q1 to Q2 direction ಅಲ್ಲಿ ಇದೆ. ಸೊ ಅದನ್ನ R12 ಅಂತ ತಗೊಂಡಿದ್ದಾರೆ, ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಯೂನಿಟ್ ವೆಕ್ಟರ್ ನ ಬರೆದಿದ್ದಾರೆ. Okay, so this is how you have to get the direction of unit vectors. Okay, so direction of unit vectors na henge baritira? So you're supposed to mark it in terms of the unit vector, and you should know whether they are attracting or repelling. Okay, is that clear? Hope we can move ahead. Yeah. So next is, this is again we are writing in the position vector notation. Okay, sometimes if the data is in terms of position vector of the two charges, r1 ಮತ್ತೆ r2 position vector notation ಕೊಟ್ಟಿದ್ರೆ, like xi cap plus yj cap ಆ ತರ ಏನೋ ಕೊಟ್ಟಿರ್ತಾರೆ, 2i cap plus 3j cap ಆ ತರ ಇರುತ್ತೆ. And the second charge is located at 5i cap plus 7j cap ಆ ತರ ಇದ್ರೆ ಹೆಂಗೆ ಬರಿಬೇಕು ಕೂಲುಮ್ಸ್ ಲಾ? ಸೊ ನಿಮಗೆ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡಲ್ ಏನು ಡೌಟ್ ಬರಬಾರದು. k q1 q2 by the distance square ಬೇಕು. ಇಲ್ಲಿ distance between q1 q2 ಏನು? So this vector is representing the distance between q1 to q2. So ಅದಕ್ಕೆ if I say r let us say r12, okay, anyway in the denominator it's not going to be a problem because we have only magnitude here. Okay, so if I just use the vector addition principle here, so ಏನು ಬರಿಬೋದು ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, this is r2 from the diagram, r2 vector plus r21 vector is equals to r1 vector ಇದೆ. Triangular law of vector addition apply ಮಾಡಿ, two vectors taken in the same order, third vector taken in the reverse direction is going to give us the resultant of two vectors. Okay, so ಏನಾಗಿರುತ್ತೆ, r2 vector plus r21 vector is equals to r1 ಆಗುತ್ತೆ, or my r21 vector is equals to r1 vector minus r2 vector. Okay, this is from the triangular law of vector addition. So ಇಲ್ಲಿ arrow ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ, this is taken in this direction, then r21 ಇಂದ ಏನಾಗಿದೆ again in the same direction, but r1 in the reverse direction ಇದೆ. So r21 vector is equals to r1 vector minus r2 vector ಆಗುತ್ತೆ. ಅದರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಇಲ್ಲಿ ಬರ್ದಿರೋದು. ಓಕೆ, ಅಂಡ್ ಡೈರೆಕ್ಷನ್ ಏನಾಗಿದೆ, ಫೋರ್ಸ್ ಆನ್ q1 ಡ್ಯೂ ಟು q2 ಅವೇ ಇರುತ್ತಲ್ವಾ. ಅಗೈನ್ ಇಲ್ಲಿ f12 ಡೈರೆಕ್ಷನ್ ಏನಾಗಿರುತ್ತೆ, ಅಗೈನ್ ದೇ ವಿಲ್ ಬಿ ರಿಪೆಲಿಂಗ್ ಈಚ್ ಅದರ್. ಸೊ ಯುವರ್ q1 ವಿಲ್ ಬಿ ರಿಪೆಲ್ಡ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್. ಓಕೆ, q1 ವಿಲ್ ಬಿ ರಿಪೆಲ್ಡ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್. ಸೊ ಆ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರೋ ವೆಕ್ಟರ್ ಯಾವುದು, ಅವರ್ r21 ವೆಕ್ಟರ್. ಓಕೆ, ಸೊ ಅದನ್ನೇ ಇಲ್ಲಿ ಬರೆದಿದ್ದಾರೆ r1 ಮೈನಸ್ r2. ಯೂನಿಟ್ ವೆಕ್ಟರ್ ಬರಿಬೇಕಿತ್ತು, ಯೂನಿಟ್ ವೆಕ್ಟರ್ ಬದಲು ಏನ್ ಮಾಡಿದ್ದಾರೆ ನಿಮ್ಗೆ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಕ್ಯೂಬ್ ಇದೆ. ಸೊ ಅದನ್ನ ನೀವು ಕರೆಕ್ಟ್ ಆಗಿ ನೋಡ್ಬೇಕು ಇಲ್ಲಿ. ಓಕೆ, ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಏನಿದೆ, ಕ್ಯೂಬ್ ಇದೆ, ಅದನ್ನು ಬರಿತೀನಿ ನಾನು. ಸೊ ಏನು, r21 cap will be what, full vector by its magnitude, r1 minus r2 vector divided by r1 minus r2 vector in a magnitude. Okay, so illi instead of r21 cap full vector in the multiply ಮಾಡಿದ್ದಾರೆ, just to balance that ನಿಮಗೆ denominator ಅಲ್ಲಿ power 2 ಇಲ್ಲ 3 ಆಗಿರುತ್ತೆ. Okay, so that is the substitution they had done. Hope it is clear till here. Yeah, kindly respond if you are following. Okay, going ahead. Yeah, so this is one thing which I have already told you a little bit. So ಏನಾಗುತ್ತೆ, depending on the dielectric medium between the two charges. So for example, here is q1, here is q2, separated by some distance r. Okay, so ಈಗ if this entire region is filled, okay, full region is filled with some dielectric medium of constant k, of dielectric constant k. So ಆಗ ಏನಾಗುತ್ತೆ, yeah, we know that force in air or vacuum ಹೆಂಗ್ ಬರಿತೀವಿ, 1 by 4 pi epsilon naught q1 q2 by r square ಅಂತ ಬರಿತೀವಿ. ಅದೇ ತರ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಮೀಡಿಯಂ ಇದ್ರೆ ಏನಾಗಿರುತ್ತೆ, 1 by 4 pi epsilon naught badlu I can say epsilon naught. Okay, k epsilon naught I'll write here. K epsilon naught into q1 q2 by r square ಆಗುತ್ತೆ. Okay, or ಇಲ್ಲಿ resubstitute ಮಾಡ್ಬೋದು. Force in medium. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, just you leave this k. Apart from that, everything is giving us the force in medium, right? 1 by 4 pi epsilon naught q1 q2 by r square is nothing but force in air divided by k. Okay, force in medium is force in air by k. Okay, or you can also say force in air by epsilon r, that is relative permittivity. So I'll write here epsilon r is nothing but k here, which is nothing but epsilon m by epsilon naught. Okay, so epsilon m ಬೇಕಂದ್ರೆ ಏನು ಮಾಡ್ತೀರಾ, it is k times of epsilon naught. Okay, so this is the substitution which we are following. Is that clear? Any doubts? Okay, so the next concept is when a dielectric medium of thickness T is partially filled between the charges, then effective air separation is given by. So ಇಲ್ಲಿ ಏನಾಗಿದೆ, so let me say the same situation is like q1 is there and q2 is there and the distance between them is r. But ಇಲ್ಲಿ we are not filling the dielectric medium fully, but instead of that what we are doing, we are just partially filling it. Okay, so ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, so let us say we are partially filling it of some thickness T. This is thickness T. Okay, so the distance between q1 to q2 is r, but dielectric medium ಎಷ್ಟು introduce ಮಾಡಿದ್ವಿ, not to the full distance r but to a thickness of T. So ಆ ಕೇಸಲ್ಲಿ ನಿಮ್ಗೆ ಇಲ್ಲಿ ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಏನು r ಸ್ಕ್ವೇರ್ ಇದೆ ಅಲ್ಲ, ಓಕೆ, ಸೊ ಅದು ಹೆಂಗೆ ಚೇಂಜ್ ಆಗುತ್ತೆ, we have to replace by this term. Okay, r effective ಅಂತ ತಗೊಂಡ್ರೆ, let me say r effective is equals to r minus t plus t root k ಆಗುತ್ತೆ. Or if you just write down the new force in this case, okay, force new is equals to 1 by 4 pi epsilon naught q1 q2 by r square ಇರುತ್ತಲ್ಲ, ಸೊ ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀರಾ, r minus t plus t root k whole square. Instead of r square ಜಾಗದಲ್ಲಿ ಏನು ಬರಿಬೇಕು, effective separation. Okay, r minus t plus t root k whole square ಆಗುತ್ತೆ. Okay, or you can say like force in air divided by this effective distance. Okay, new force will be equal to ಹೆಂಗೆ ಚೇಂಜ್ ಆಗಿರುತ್ತೆ, new force is equals to force in air divided by r minus t. Okay, we cannot say like that because force in air ಮಾಡ್ಬೇಕಾದ್ರೆ ಅಲ್ಲಿ ನಮಗೆ r square term ಇರುತ್ತೆ denominator ಅಲ್ಲಿ, so you cannot say like that. So it just gives you the effective distance ಏನು ತಗೊಳ್ಬೇಕು. Okay, so yeah, 1 by 4 pi epsilon naught q1 q2 by r minus t plus t root k whole square. Okay, is that clear? Any doubts? If you are following, just give me a thumbs up or please respond in the chat box. So if you converse, then only the session becomes more effective. Hope you are following. Okay, quickly smash the like button if you're following the session, or you can also like, you can give me a thumbs up in the chat box as well, and please do mark your attendance. Okay, so I think we can go ahead. So this is about how the force changes when the medium, in some dielectric medium, apart from air or vacuum, if we introduce some dielectric medium with dielectric constant K. So ಇಲ್ಲಿ K ಅಂದ್ರೆ ಏನು, dielectric constant. Okay, so this is how it appears. Fine. So next to go ahead is the another important concept, that is superposition principle. Okay, so what do you mean by superposition principle? So ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಕೂಲಮ್ಸ್ ಲಾ ಬರಿಬೇಕಾದ್ರೆ ನಾವು ಎರಡೇ ಚಾರ್ಜಿಗೆ ಅಪ್ಲೈ ಮಾಡೋದು, ರೈಟ್? ದ ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ ಟೂ ಚಾರ್ಜಸ್ ವಿಲ್ ಟಾಕ್. ಸೊ ನಾವು ಇಫ್ ಯು ಆರ್ ಗಿವನ್ ವಿತ್ ಸಿಸ್ಟಮ್ ಆಫ್ ಚಾರ್ಜಸ್, ಲೈಕ್ n ನಂಬರ್ ಆಫ್ ಚಾರ್ಜಸ್ ಇದೆ, ಸೊ ಫೋರ್ಸ್ ಆನ್ ಎನಿ ಒನ್ ಚಾರ್ಜ್ ಬೇಕು, ಆಗ ಏನಾಗಿರುತ್ತೆ, ಸೊ ದ ನೆಟ್ ಫೋರ್ಸ್ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು ದಿ ವೆಕ್ಟರ್ ಸಮ್ ಆಫ್ ಇಂಡಿವಿಜುವಲ್ ಫೋರ್ಸಸ್ ಆಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ ಹೆಂಗೆ ಡಿಫೈನ್ ಮಾಡ್ಬೋದು? ಲೆಟ್ ಮೀ ಸೇ I have a charge Q here, okay, and there are several charges. Let me say this is Q1, Q2, Q3 at various distance, let us say R1, R2, R3. You may have n number of charges. The corresponding distance, let it be as Rn. So the net force on this charge Q, okay, net force on charge Q, net force on charge Q ಏನಾಗುತ್ತೆ, ಹೆಂಗ್ ಬರಿತೀವಿ? So that is the vector sum of individual forces. So ಇಲ್ಲಿ F1 ಅಂದ್ರೇನು, force between Q and Q1. ಹೆಂಗ್ ಬರಿಬೋದು? 1 by 4 pi epsilon naught Q into Q1 by R1 square. Similarly F2 ಹೆಂಗ್ ಬರಿತೀರಾ? 1 by 4 pi epsilon naught Q Q2 by R2 square. And ಅದರ direction ತಗೋಬೇಕು. It is the vector sum. Okay, you had to understand vector sum. It's the vector sum of individual forces. Okay, so that is what is your superposition principle is about. Presence of other charge will not affect the force between these two charge. Andre ಏನರ್ಥ? So here the presence of Q2 is not going to alter the force between Q1 and Q. Okay, that will be there as F1, but extra F2 will also be there, F3 will also be there. There is no effect on the force on Q because of the presence of any other charges. Okay, so that is your principle of superposition. Okay, is that clear? Any doubt? Any doubt in superposition principle? Yeah, if you had doubts, you can kindly ask here. So moving ahead, so ಇಲ್ಲಿ ಒಂದು formula ಕೊಡ್ತೀನಿ which is important in terms of solving the problems. It's just the vector addition formula I'm giving you. So let us say we have two forces, okay, F1 and F2. Angle between F1 and F2, let it be as theta. ಈಗ ಇವೆರಡರ resultant magnitude ಮತ್ತೆ direction ಅಂತ. Okay, so let me say F net, and this is the angle alpha. Okay, so we have two forces, F1 and F2. So resultant ಅನ್ನ F net ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ. Okay, so angle between F1 and F2 ಎಷ್ಟಿದೆ? theta. Okay, alpha is the angle between F net and F1. So ಈಗ magnitude of the resultant force ಹೆಂಗ್ ಬರಿತೀವಿ? So if you just recall your addition of two vectors or the resultant of two vectors ಹೆಂಗ್ ಬರಿತೀವಿ r is equals to square root of a square plus b square plus 2ab cos theta ಬರಿತೀವಲ್ಲ. ಸೊ ಅದೇ ತರನೇ ಅದನ್ನೇ ಬರಿತಾ ಇರೋದು in terms of f1 f2 notation. f1 square plus f2 square plus 2f1 f2 cos theta. Okay, and direction andre tan alpha, which is given by f2 sin theta divided by f1 plus f2 cos theta. Okay, so this is giving us the direction, whereas this is giving us the magnitude of the resultant force. Okay, so this one formula you need it when we are having two forces acting at certain angle. So how to find the resultant of those two vectors? So please remember this formula. Okay, any doubt till here? Okay, I think we can go ahead. Yeah. So the next thing we are going to discuss is, which is electric field intensity, which is usually represented by E. Okay, so how do we define electric field intensity? It is a force experienced per unit positive charge. So let me say I have a charge capital Q. I call this as source charge, and at some distance, okay, I want to see how strong this charge is. So to know that, we need a physical quantity, which is our electric field intensity. Force and define ಮಾಡಿದ್ರೆ always it depends on the two charges ಆಗುತ್ತೆ. ಕೊಟ್ಟಿರುವ ಒಂದೇ ಸೋರ್ಸ್ ಚಾರ್ಜ್ ನ ಎಬಿಲಿಟಿ ಅಥವಾ ಎಷ್ಟು ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ನ ಜನರೇಟ್ ಮಾಡ್ತಿದೆ ಅಂತ ನೋಡ್ಬೇಕಂದ್ರೇನು. ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಟಾಕ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಂಟೆನ್ಸಿಟಿ. ಸೊ ಇಲ್ಲೇನ್ ಮಾಡ್ತೀನಿ, ನಾನೊಂದು ಚಾರ್ಜ್ Q0 ಅಂತ ಪ್ಲೇಸ್ ಮಾಡ್ತೀನಿ, which is I call it as test charge. So ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, this Q0 is always positive. Okay, Q0 is always positive. We take always test charge positive, and it is very small, so that this Q0 will not affect the existing field due to our source charge. Okay, the field due to test charge should be so small or so negligible that it should not alter the existing field, because my idea is to find out what is the electric field due to this source charge. No, test charge ಇನ್ನೊಂದಷ್ಟು ಫೀಲ್ಡ್ ಕೊಟ್ರೆ ನಮ್ಗಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, again ಎಲ್ಲ ಆಡ್ ಅಪ್ ಆಗ್ಬಿಟ್ಟಿರುತ್ತೆ. ಸೊ ನಾವೇನ್ ತಗೋತೀವಿ, ಒಂದು ಸ್ಮಾಲ್ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ತಗೊಂತೀವಿ, and what is the force experienced by unit positive charge? ಹೆಂಗ್ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ, electric field E is equals to F by Q0 ಅಂತ ತಗೊಂತೀವಿ, force per unit charge. Okay, if Q0 ಇಲ್ಲಿ force between Q0 ಬೇಕಂದ್ರೆ ಹೆಂಗ್ ಬರ್ದಿರ್ತೀರಾ, 1 by 4 pi epsilon naught Q0 by distance square ಅಂತ ಬರ್ದಿರ್ತೀರಾ, ಕರೆಕ್ಟಾ? ಯಾ 1 by 4 pi epsilon naught Q0 by R square ಅಂತ ಬರ್ದಿರ್ತೀರಾ. ಸೊ ಈಗ ಒಂದು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇಟ್ರೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗ್ತಿದೆ ಅನ್ನೋದು ಅವರ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಸೊ E is equals to F by Q0. Okay, yes, Chetan, source charge ಅಂದ್ರೆ ಏನು, we are talking about some electrostatic phenomena. Let us say I have a charged body, let us say, okay, ಯಾವುದೋ ಒಂದು charged body ಇದೆ. Okay, so next ನಾನು ಇಲ್ಲಿ ಇನ್ಯಾವುದೋ ಒಂದು charged body, okay, I want to study the electrical phenomena of this body. ಓಕೆ, ಸೊ ಈಗ ಇದರಲ್ಲಿ ಚಾರ್ಜ್ ಇದೆಯಾ ನೋಡ್ಬೇಕು ಅಂದ್ರೂ ನಾನು ಇನ್ನೊಂದು ಚಾರ್ಜ್ ಬಾಡಿನೇ ತರಬೇಕು. ವೆದರ್ ಅಟ್ರಾಕ್ಟ್ ಆಗುತ್ತಾ, ರಿಪೆಲ್ ಆಗುತ್ತಾ, ಎಷ್ಟು ಸ್ಟ್ರಾಂಗ್ ಇದೆ ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೇಕಂದ್ರೂ ನಂಗೆ ಏನೋ ಒಂದು ಪ್ಯಾರಾಮೀಟರ್ ಬೇಕು. ಫೋರ್ಸ್ ವಿಲ್ ನಾಟ್ ಟೆಲ್ ಅಸ್ ದಟ್, ಬಿಕಾಸ್ ಇಲ್ಲಿ ಎರಡೂ ಚಾರ್ಜ್ ಮೇಲೂ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ ಫೋರ್ಸ್. ಓಕೆ, ಬಟ್ ಈ ಚಾರ್ಜ್ ಆರ್ ಈ ಚಾರ್ಜ್ ಬಾಡಿ ಎಷ್ಟು ಸ್ಟ್ರಾಂಗ್ ಇದೆ ಅಂತ ಗೊತ್ತಾಗ್ಬೇಕು ಅಂದ್ರೆ ಐ ನೀಡ್ ಟು ಬ್ರಿಂಗ್ ಒನ್ ಸ್ಮಾಲ್ ಟೆಸ್ಟ್ ಚಾರ್ಜ್. ಆ ಸ್ಮಾಲ್ ಚಾರ್ಜ್ ನಾವು ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಅನ್ನೋದು, ಅಂದ್ರೆ ಅದನ್ನ ಟೆಸ್ಟ್ ಮಾಡಕ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಷ್ಟೇ. ಓಕೆ, ಅಂಡ್ ವಿಚ್ ಇಸ್ ಆಕ್ಚುಲಿ ಕಾಸಿಂಗ್ ದಿ ಬಿಗ್ಗರ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್, ದಟ್ ಈಸ್ ಮೈ ಸೋರ್ಸ್ ಚಾರ್ಜ್. ಓಕೆ, ಸೊ ಸೋರ್ಸ್ ಚಾರ್ಜ್ ಅಂದ್ರೆ ಏನು, ಯಾವುದು ನಮಗೆ ಎಕ್ಸಿಸ್ಟಿಂಗ್ ಫೀಲ್ಡ್ ಕೊಡ್ತಾ ಇರುತ್ತಲ್ಲ, ಅಲ್ಲಿ ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಆಗಿರ್ಲಿ, ಏನೋ ಒಂದು ಫಿನಾಮಿನಾ, ಅದು ಇಟ್ ಮೈಟ್ ಬಿ ಕಾಸಿಂಗ್ ಸಮ್ ಪೊಟೆನ್ಷಿಯಲ್. ಓಕೆ, ಸೊ ಅದನ್ನ ನಾವು ಸೋರ್ಸ್ ಚಾರ್ಜ್ ಅಂತ ಕರಿತೀವಿ. Okay, it's our source. It is causing all sorts of electrical phenomena, maybe field, potential, force, whatever it may be. So this is my source, but our source na check madak nange enaru bekalla, that is my test charge. Our source ಎಷ್ಟು ಸ್ಟ್ರಾಂಗ್ ಇದೆ, ಅದರ ಫೀಲ್ಡ್ ಎಷ್ಟಿದೆ ನೋಡ್ಬೇಕು ಅಂದ್ರೆ ನಾ ಇನ್ನೊಂದು ಚಾರ್ಜ್ ತಂದು ಚೆಕ್ ಮಾಡ್ಬೇಕಲ್ಲ. ಸೊ ದಟ್ ಈಸ್ ಮೈ ಟೆಸ್ಟ್ ಚಾರ್ಜ್. ಸೋರ್ಸ್ ಚಾರ್ಜ್ ಇಸ್ ದ ಚಾರ್ಜ್ ಆಫ್ ಅವರ್ ಇಂಟ್ರೆಸ್ಟ್. ಓಕೆ, ಇದರಿಂದ ಎಲ್ಲ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಫಿನಾಮಿನಾ ಬಂದಿದೆ, ನಂಗೆ ಇದನ್ನ ಸ್ಟಡಿ ಮಾಡಬೇಕು. ಸೊ ಹೌ ಮಚ್ ಇಟ್ ಇಸ್ ಗಿವಿಂಗ್ ಅಸ್ the field or the force, or what is its boundary, adella that is source charge, which is causing all the electrical effect. Source for all the electrical effect which we are studying for now. Okay, is that clear, Chetan? Hope it is clear what is a source charge and a test charge. Yeah, kindly respond. If you are there, kindly respond, Chetan. Okay. There's one more notation, as I said, to define our electric field. So, in ಮಾಡ್ತೀವಿ, our electric field is limit, okay, Q0 tending to 0, F by Q0 ಅಂತ ತಗೊಂತೀವಿ. Okay, so just to say this test charge is small, it is not affecting the existing electric field andrenu, this Q0 should be as small as possible. Okay, so under the limit of Q0 tending to 0 alla, but small charge ide, so force experienced per this test charge is going to give us the electric field. So this is another way of writing the electric field. Okay, is that clear? Any doubt? Okay, Chetan, thanks for your response. Hope it is clear. Next is electric field due to system of charges or superposition principle. This is just like your how you had done for force, no? The same way, the field due to system of charges will be the vector sum of individual field intensities. Okay, so the net electric field beku andre I should do the vector sum of electric field due to all the individual charges. Okay, if n number of charges are there, so you have to do the vector sum of individual electric fields. Is that clear? So that's how you do superposition principle. Again, it is very basic because existing the force or the field between two charge is not going to be affected by the presence of any other charges. Okay, averder interaction hange irutte, but net field nodidaga add athwa subtract agirutte depending on its direction. So illi vector sum ಮಾಡಬೇಕು, normal sum ಮಾಡ್ತಾ ಇರೋದಿಲ್ಲ ನಾವು, ಅದೊಂದು ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಿರಬೇಕು. Okay, is it clear? So this is about the superposition principle. Any doubts till here? So one expression, where do I write? Okay, I think in the next it is there. Yeah, I'll give here itself later. Any doubts? Okay, so let's take a short break for 5 minutes and then we'll continue. Okay, be back by 6:15. Or I can say 18, sorry, 5 minutes break. No, it is almost 6:15, 6:20. Okay, so just take a short break for 5 minutes and come back by 6:20. Okay. Am I audible? Welcome back to the session. Shall we continue? Hope I am audible and visible now. Could you respond once that you're there? Am I audible? Welcome back. Yeah, I think it's fine here. So what we are discussing is with respect to electric field and superposition principle, correct? So there's 1 minute. Yeah. So there is two things that I'll give you, and then we'll take up some problems, and then I'll continue the theory part. So here, if instead of discrete charges, most of the time we'll be given with some discrete charges, right? So if instead of some discrete charges, if we are given with continuous charge distribution, like the charge is distributed over, some surface, might be in a 2-dimension or about a line in 1 dimension. The charge is, uniformly or non-uniformly, but it is distributed all over a line, all over a surface, or in a 3-dimension like a sphere. Okay, the charge is distributed entirely inside a sphere, 3-dimensional one. So our timely, instead of talking in terms of charge, sometimes it becomes easy to talk in terms of charge distribution or charge density. Okay, so other 3 types of charge density we will define. So one is linear charge density. So it is usually represented by the symbol lambda. Okay, so lambda is going to be charge per unit length. So one thin line tagondre, so the charge is distributed over the length of this wire. Okay, so heng define ಮಾಡ್ತೀವಿ charge per unit length. Okay, so that is lambda is equals to charge, total charge q idre. Okay, the total charge on that entire line q idre heng baribodu q by l, charge by length. So unit ಏನಾಗಿರುತ್ತೆ ಕೂಲಂಬ್ per meter ಆಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ ಇದನ್ನ ನಾವು ಲೀನಿಯರ್ ಚಾರ್ಜ್ ಡೆನ್ಸಿಟಿ ಅಂತ ಕರಿತೀವಿ. ಚಾರ್ಜ್ ಪರ್ ಯೂನಿಟ್ ಲೆಂತ್, ನೇಮೇ ಹೇಳುತ್ತಲ್ವಾ ಲೀನಿಯರ್ ಚಾರ್ಜ್ ಡೆನ್ಸಿಟಿ ಅಂದ್ರೆ. ಸೊ ಚಾರ್ಜ್ ಇಸ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ಓವರ್ 1 dimension. ನೆಕ್ಸ್ಟ್ ಸರ್ಫೇಸ್ ಚಾರ್ಜ್ ಡೆನ್ಸಿಟಿ. ಸೊ ಇಫ್ ವಿ ಹ್ಯಾವ್ ಎ ಸರ್ಫೇಸ್ ಲೈಕ್ ದಿಸ್, ದ ಚಾರ್ಜ್ ಇಸ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ಫಾರ್ ದಿ ಎಂಟೈರ್ ಏರಿಯಾ. ಓಕೆ, ಸೊ ಅದನ್ನ ಸರ್ಫೇಸ್ ಚಾರ್ಜ್ ಡೆನ್ಸಿಟಿ ಅಂತ ಕರಿತೀವಿ. ಯೂಶುವಲ್ ನೊಟೇಷನ್ ಸಿಗ್ಮಾ. ಓಕೆ, charge per unit area. Okay, so heng baritivi sigma is equals to total charge again q anta tagondre q by a. Unit ಏನಾಗಿರುತ್ತೆ ಕೂಲಂಬ್ per meter square. Okay, yes, if you are following and if you are back from the break, kindly let me know whether you're following or not. Okay, hope you're all back from the break. It was a short break given. Yeah. Okay, I think we can continue. So next is volume charge density. Volume charge density andre, so entire volume ali charge distribute agutte. You can imagine like a hollow sphere. So charge full ali volume ali distribute agutte. So ಆ case ಅಲ್ಲಿ so ಏನು ಮಾಡ್ತೀವಿ ನಾವು, in this case rho is the notation. Okay, sigma for surface charge density, volume charge density ಗೆ rho ತಗೊಂತೀವಿ, ಇಲ್ಲಿ charge per unit volume. Okay, charge per unit volume. Okay, so again rho is equals to total charge q by the volume v, and unit heng baribodu coulomb per meter cube. Okay, is that clear? Any doubts? If you had some doubts, you can feel free to ask and ask in the chat box as well. So when we are having a continuous charge distribution, so 3 types of charge density define ಮಾಡ್ತೀವಿ. So one is line charge density or linear charge density, second is surface charge density, and the third is volume charge density. Okay, is that clear? And if you have just joined now, please mark your attendance. Okay, so going ahead, so electric field due to a point charge. So one point charge kotre adara electric field hengirutte anta kelidare. So if we consider the 2 point charges, okay, so let me say, or 1 point charge tagondri antane ankoli. So we have a charge q and I may have another charge q naught here. I want to find out the electric field due to this, and let me say the distances are. Okay, so the total distance between q to q naught na r anta tagondre. So ಈಗ field due to this point charge q ಹೆಂಗ್ ಬರಿಬಹುದು? So electric field is E. Okay, E is equals to force by q naught anta ಬರಿತೀವಿ, correct? But force ಹೆಂಗ್ ಬರಿತೀವಿ? From Coulomb's law I can say F is equals to 1 by 4 pi epsilon naught q naught by r square ಅಂತ ಬರಿಬಹುದು. ಸೊ ಅದನ್ನೆಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. 1 by 4 pi epsilon naught q naught by r square whole divided by q naught ಆಗುತ್ತೆ. So this q naught and this q naught will go away. So ಏನು ಉಳಿಯುತ್ತೆ ನಮಗೆ? Electric field is equals to 1 by 4 pi epsilon naught q by r square. So ಈಗ I think you will understand. Yeah, so this is purely dependent on what is the value of the given source charge. So q mel matra depend agirutte. So it will tell me how strong the field, which I was interested to see. Okay, how strong the field is being generated by this source charge. So ಅದಕ್ಕೆ ಇಲ್ಲಿ ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನ ಡಿಫೈನ್ ಮಾಡೋದು. ಇಲ್ಲ ಅಂದ್ರೆ ಫೋರ್ಸ್ ಜೊತೆಗೆ ಡಿಸ್ಕಸ್ ಮಾಡಬಹುದಾಗಿತ್ತು, ಬಟ್ ಫೋರ್ಸ್ ಅನ್ನೋದು ಏನಾಗಿರುತ್ತೆ, ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಬೋತ್ ದಿ ಚಾರ್ಜಸ್. ನಂಗೆ ಯಾವುದೋ ಒಂದು ಫೀಲ್ಡ್ ಜನರೇಟ್ ಆಗಿದೆ ಒಂದು ಚಾರ್ಜಿನ ಸುತ್ತ, ಎಷ್ಟು ಸ್ಟ್ರಾಂಗ್ ಇದೆ ಆ ಚಾರ್ಜ್ ಅಂತ ನೋಡ್ಬೇಕಂದ್ರೆ ಅದರ ಫೀಲ್ಡ್ ಬೇಕು ನನಗೆ, ಫೀಲ್ಡ್ ಅಂಡ್ ಫೀಲ್ಡ್ ಸ್ಟ್ರೆಂತ್. ಓಕೆ, ಸೊ ದ್ಯಾಟ್ ಈಸ್ ವಾಟ್ ಇಸ್ ಯೋರ್ electric field is all about. Okay, yeah. So going ahead, direction of field. So electric field direction along the direction of force antane helbodu in one way, or you can say for positive charge field is away from it. Field is away from the charge. Okay, so if I have a space here, okay, I'll write here as 2 points regarding the direction of electric field. Okay, so ಏನಾಗಿರುತ್ತೆ, for positive charge electric field direction is away from the charge. Field is away from the charge. Okay, along the direction of force ಅಂತಾನೆ ಹೇಳ್ಬೋದು, correct? And next is negative charge ಇದ್ರೆ field direction ಏನಾಗಿರುತ್ತೆ, towards the charge ಆಗಿರುತ್ತೆ. Okay, so if this source charge is negative ಆಗಿದ್ರೆ ಏನಾಗಿರ್ತಿತ್ತು, this q naught has a tendency to get attracted towards the source charge. Okay, so this is giving me the direction of electric field agirodu. Ade if the source charge is positive, so this q naught has a tendency to move away, that is the direction of force, right? So your electric field direction is along the direction of the force agirutte. Okay, is that clear? So that is how you get the direction of electric field. So now there are a few more formulas I had to give you regarding electric field, so which I'll discuss after doing some MCQs, because we'll work out some problems so that you get an idea, like till now what we have discussed, how to apply those formulas and concepts to the actual numericals. Okay, so here is our first problem. 2 point charges 1 microcoulomb and 5 microcoulomb are separated by a certain distance. What will be ratio of force acting on these two? So ಎರಡು point charge ಕೊಟ್ಟಿದ್ದಾರೆ. It's a very simple question. So some of you can try answering it. Yes, you can respond in the chat box. So ಏನು ಎರಡು charge ಇದೆ, 1 microcoulomb and 5 microcoulomb separated by certain distance d ಅಂತ ಬರ್ಕೊಳ್ಳೋಣ. Okay, what will be the ratio of the force? ಸೊ ಈ 1 microcoulomb ನ ನಾನು q1 ಅಂತ ತಗೋತೀನಿ, 5 microcoulomb ನ q2 ಅಂತ ತಗೊಂತೀವಿ. ಓಕೆ, ಸೊ ಈಗ ಫೋರ್ಸ್ ಆನ್ 1 ಡ್ಯೂ ಟು 2 ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಬರೆದ್ರೆ ಏನಾಗಿರುತ್ತೆ? ಸೊ ದಟ್ ಇಸ್ 1 by 4 pi epsilon naught q1 q2 by r square ಆಗಿರುತ್ತೆ. ಅದೇ ತರ F21 ತಗೊಂಡ್ರೆ ದಟ್ ಇಸ್ ಫೋರ್ಸ್ ಆನ್ q2 ಡ್ಯೂ ಟು q1. ಸೊ ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ? 1 by 4 pi epsilon naught again q1 q2 by r square ಆಗಿರುತ್ತೆ. Okay, so the Coulomb force between two charges, okay, will be always equal and opposite. Their magnitudes are always same. F12 vector magnitude is equals to F21 vector magnitude ಆಗಿರುತ್ತೆ. Okay, so that means it is ratio ಏನಾಗಿರುತ್ತೆ? is 1:1 ratio. Magnitude same, only the direction will be opposite. Correct? Magnitude of force between the two charges will be same. Direction will be opposite to each other. Okay, direction will be opposite to each other irutte. So magnitude ratio same irodrinda we can say like 1:1 force alla irutte. It is not 1:5 or 5:1. ನಿಮಗೆ ಒಂದೊಂದ್ಸತಿ ಮಿಸ್ಕನ್ಸೆಪ್ಷನ್ ಆಗ್ಬೋದು, ಓಕೆ q2 ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಜಾಸ್ತಿ ಇದೆ ಸೊ ಇದರ ಫೋರ್ಸ್ ಜಾಸ್ತಿ ಆಗಿರುತ್ತೆ. ನೋ, ಇಟ್ ಇಸ್ ನಾಟ್ ಲೈಕ್ ದಟ್. ಓಕೆ, ಬಿಕಾಸ್ ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ ದಿ ಟೂ ಚಾರ್ಜ್ ಎನಿವೇ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದಿ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ದಿ ಟೂ ಚಾರ್ಜಸ್ ಆಗಿರುತ್ತೆ. ಸೊ ರೇಷಿಯೋ ತಗೊಂಡಾಗ ಅದರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ಸ್ ರೇಷಿಯೋ 1:1 ಇರುತ್ತೆ. If there is an option like 1:-1, then you have to mark 1:-1 because that is more precise. ಅದರಲ್ಲಿ ಡೈರೆಕ್ಷನ್ ಅನ್ನು ನಾವು ಇನ್ಕ್ಲೂಡ್ ಮಾಡಿದೀವಿ. ಓಕೆ, ಯಾ, ಸೊ they will be equal and opposite. Equal and opposite. In the vector notation ಹೆಂಗ್ ಬರಿಬೋದು? In vector notation ತಗೊಂಡ್ರೆ F21 vector will be equal to minus of F12 vector. Okay, so ಈ ಕೇಸಲ್ಲಿ 1:-1 ತಗೋಬೇಕಾಗುತ್ತೆ. ಅಲ್ಲಿ ಆಪ್ಷನ್ ಇಲ್ಲ, ಸೊ ನೋ ನೀಡ್ ಟು ವರಿ. Okay, hope it is clear. Yeah, so moving to next question. So ಇದಕ್ಕೆ option 3 is the correct answer. Okay, so moving to next question. If you are there, kindly respond. We can quickly move to, we can quickly solve some MCQs. So that is 2 point charges 3 microcoulomb and 8 microcoulomb repel each other with a force of 40 Newton. If a charge of -5 microcoulomb is added to each of them, then the force between them will become. Okay, so initially let me say Q1 is equals to 3 microcoulomb, Q2 is equals to 8 microcoulomb ಇದೆ. And ಈ ಕೇಸಲ್ಲಿ I'll just take, ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಫ್ರಮ್ ವಿ ಆರ್ ಗಿವನ್ ವಿತ್ 2 ಕೇಸ್, ಅದರಲ್ಲಿ ಚಾರ್ಜ್ ಡಿಫ್ರೆಂಟ್ ಆಗಿದೆ. ಕರೆಕ್ಟ್? ಸೊ ಫಸ್ಟ್ ಕೇಸಲ್ಲಿ ಚಾರ್ಜು 3 and 8 ಇದೆ. ನೆಕ್ಸ್ಟ್ ಕೇಸಲ್ಲಿ ಏನ್ ಮಾಡಿದಿರಿ? -5 microcoulomb ಆಡ್ ಮಾಡಿದೀವಿ. ಓನ್ಲಿ Q1 Q2 ಚೇಂಜ್ ಆಗ್ತದೆ, ಡಿಸ್ಟೆನ್ಸ್ ಏನು ಚೇಂಜ್ ಆಗ್ತಾ ಇಲ್ಲ. ಸೊ I'll just consider force is directly proportional to the product of magnitude of the two charges, right? ಸೊ ಈಗ ಫಸ್ಟ್ ಕೇಸಿಗೆ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಏನ್ ಹೇಳ್ಬೋದು? F is directly proportional to 3 into 8. Okay, so I am not even taking that microcoulomb because anyway ಎರಡು ಕೇಸಲ್ಲೂ ಮೈಕ್ರೋ ಕೂಲುಂಬೇ ಇದೆ. ಸೊ ಅದು ನೀವು ರೇಷಿಯೋ ತಗೊಂಡಾಗ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೆಕೆಂಡ್ ಕೇಸ್ನ ನಾನು Q1 ಡ್ಯಾಶ್ ಅಂತ ತಗೊಂತೀನಿ. ಸೊ ಇಲ್ಲೇನಾಗಿರುತ್ತೆ, 3 ಮೈಕ್ರೋ ಕೂಲುಮ್ಗೆ -5 ಮೈಕ್ರೋ ಕೂಲುಮ್ನ ಆ್ಯಡ್ ಮಾಡಿದ್ದೀವಿ. ಸೊ ಆಗ ನಮಗೇನು ಬರುತ್ತೆ, -2 ಮೈಕ್ರೋ ಕೂಲುಮ್ ಬರುತ್ತೆ. ಓಕೆ, ಸೊ ಅದೇ ಥರ Q2 ಡ್ಯಾಶ್ ಏನಾಗಿದೆ, 8 ಮೈಕ್ರೋ ಕೂಲುಮ್ಗೆ -5 ಮೈಕ್ರೋ ಕೂಲುಮ್ನ ಆ್ಯಡ್ ಮಾಡಿದ್ದೀವಿ. ಸೊ ಹಿಯರ್ ವಿ ಗೆಟ್ 3 ಮೈಕ್ರೋ ಕೂಲುಮ್. ಓಕೆ, ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? Yeah, so this is micro coulomb. So ಈಗ new force F dash ಅಂತ ತಗೊಂಡ್ರೆ F dash is proportional to Q1 dash into Q2 dash ಆಗುತ್ತೆ, or this will give us F dash is proportional to -2 into 3 ಆಗುತ್ತೆ. ಈಗ ರೇಷಿಯೋ ತಗೊಂಡ್ರೆ F dash by F is equals to, so -2 into 3 divided by 3 into 8 ಆಗುತ್ತೆ, or this will give us F dash is equals to, so ಇಲ್ಲಿ F value ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ, F is given to be 40 Newton, here it is, correct? So 40 into, so this is like -6 divided by, we can just keep this as it is, 3 into 8. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ, yeah, so ಏನಾಗುತ್ತೆ, so this is like 8 1s are 8 5s are and 3 1s are 3 2s are. So this is going to give us F dash is equals to -10 Newton ಆಗುತ್ತೆ. Okay, so that is option 1, -10 Newton is the correct answer. Is that clear? Hope you are following. If you are there, kindly respond, and please do mark your attendance, and also like this session. Give me a thumbs up in the chat box so that I can go ahead as well. Quick response, quick solving. You have to be very quick in all these competitive exams. Okay, so ಇಲ್ಲಿ ಕೇರ್ಫುಲ್ ಆಗಿರಿ, ನೆಗೆಟಿವ್ ಸೈನ್ ಬಿಡಬೇಡಿ. ಫಸ್ಟ್ ಕೇಸಲ್ಲಿ ಅದು ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸು, 2 ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ. ಸೆಕೆಂಡ್ ಕೇಸಲ್ಲಿ ಏನಾಗಿದೆ, 1 ನೆಗೆಟಿವ್ ಚಾರ್ಜು 1 ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ, ಅಂದ್ರೆ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಆಗಿದೆ. ಸೊ ಅದಕ್ಕೆ ನಿಮಗೆ ಇಲ್ಲಿ ಒಂದು ನೆಗೆಟಿವ್ ಸೈನ್ ಬರುತ್ತೆ. ಓಕೆ, ಸೊ ಮಾರ್ಕ್ ಮಾಡಬೇಕಾದ್ರೆ ಕೇರ್ಫುಲ್ ಆಗಿ ಮಾರ್ಕ್ ಮಾಡಿ. ಓಕೆನಾ? ಸೊ ಮೂವಿಂಗ್ ಟು ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶನ್. 2 charges 40 microcoulomb and -20 microcoulomb are placed at a certain distance apart. They are touched and kept at the same distance. The ratio of the initial to the final force between them is. So ಇಲ್ಲಿ ಏನಾಗಿದೆ, again 2 charges ಕೊಟ್ಟಿದ್ದಾರೆ. ಓಕೆ, and ಇಲ್ಲಿ ಎಕ್ಸ್ಟ್ರಾ ಆಡ್ ಮಾಡ್ತಾ ಇಲ್ಲ, ಬಟ್ ಏನ್ ಮಾಡಿದೀವಿ, we are bringing them in contact and then we are keeping at the same distance. So ಇಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿಲ್ಲ. So I'll just consider this part. F is directly proportional to Q1 Q2 ಸಾಕು ನಂಗೆ. Q1 value ಏನು, Q2 value ಏನು in the 2 case, and take the ratio. That's all is our job. So ಏನ್ ಮಾಡಬೇಕು, first case ಅಲ್ಲಿ this I call it as Q1, this I call it as Q2. So Q1 is 40 microcoulomb, Q2 is -20 microcoulomb. Okay, so ಈ case ಅಲ್ಲಿ force is directly proportional to 40 into -20. Again ಇಲ್ಲಿ ಮೈನಸ್ ಬಿಡಬೇಡಿ. ಓಕೆ, ಬಿಕಾಸ್ ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಇಫ್ ಬೋತ್ ಕಮ್ಸ್ ಔಟ್ ಟು ಬಿ ಅಟ್ರಾಕ್ಟಿವ್, ಫೈನ್, ರೇಷನಲ್ ಆ ನೆಗೆಟಿವ್ ಸೈನ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಬಟ್ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಇಲ್ಲೇನಾಗಿದೆ, ಎನಿವೇ ಆಲ್ ಆರ್ ವಿತ್ ದ ಪಾಸಿಟಿವ್ ಸೈನ್ಸ್ ಇದೆ. ಬಟ್ ಇಫ್ ಯು ಹ್ಯಾವ್ ಒನ್ ಆರ್ ದಿ ಅದರ್ ಆಪ್ಷನ್ ಆಸ್ ನೆಗೆಟಿವ್ ಸೈನ್, ಯು ಹ್ಯಾವ್ ಟು ಬಿ ವೆರಿ ಕೇರ್ಫುಲ್. ಓಕೆ, ಸೊ ಈಗ ಬ್ರಿಂಗಿಂಗ್ ದೆಮ್ ಇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಆರ್ ದೆ ಟಚ್ಡ್ ಈಚ್ ಅದರ್ ಅಂದ್ರೆ ಏನರ್ಥ, ಸೊ ಚಾರ್ಜ್ ವಿಲ್ ಶೇರ್, ಚಾರ್ಜ್ ಶೇರ್ ಆಗತ್ತೆ, ಈಕ್ವಲ್ ಆಗಿ ಶೇರ್ ಆಗತ್ತೆ. ಓಕೆ, ಸೊ ಸೆಕೆಂಡ್ ಕೇಸ್ ಅಲ್ಲಿ ಐ ಕ್ಯಾನ್ ಸೇ Q1 dash is equals to Q2 dash ಆಗತ್ತೆ, and this will be equal to what, Q1 plus Q2 by 2 ಆಗತ್ತೆ. ಸೊ ಇಲ್ಲಿ Q1 ಅಂದ್ರೆ 40, Q2 ಅಂದ್ರೆ -20 microcoulomb whole divided by 2, so which is like 20 by 2, which is going to give you 10 microcoulomb ಆಗತ್ತೆ. ಓಕೆ, ಎರಡು ಚಾರ್ಜ್ Q1 dash Q2 dash will be equal to 10 microcoulomb ಆಗತ್ತೆ. ಓಕೆ, Hope you're following till here. Okay. So next new force F dash is proportional to Q1 dash into Q2 dash agate, or this is going to give us F dash is proportional to, so 10 into 10 ಆಗಿರತ್ತೆ. Okay, so ಈಗ ರೇಷಿಯೋ ತಗೊಳ್ಳಿ. F dash by F is equals to 10 into 10 divided by 40 into minus 20. Okay, so this is like 10 ones are 4s are, and this is like 10 ones are minus 2. Okay, so this will give you 1 by 8 with a negative sign. Okay, 1 is to 8 because ಇಲ್ಲಿ 4 ಇದೆ, ಇಲ್ಲಿ 2 ಇದೆ, 4 2s are 8. So minus 1 is to 8, or ಅಲ್ಲಿ optional ಏನಾಗಿದೆ plus ಎಲ್ಲ ಇದೆ, so we can ignore for now. If option, there is an option with plus and minus, you have to be very careful. Okay, ratio of initial to final force ಏನಾಗುತ್ತೆ 1 is to 8, option 3 is the correct answer. Okay, is that clear? Any doubt? If you're following, give me a thumbs up. Okay, moving to next question. Yeah, 3 equal charges, each Q, placed at the corners of an equilateral triangle of side A. What will be the force on any one charge? So ಯಾವುದಾದ್ರೂ ಒಂದು ಚಾರ್ಜಿನ ಮೇಲಿನ ನೆಟ್ ಫೋರ್ಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸೊ ಕೊಟ್ಟಿರೋ ಸಿಚುಯೇಷನ್ ಏನಿದೆ, so let us quickly have a diagrammatic representation. So yeah, okay, so we are having 3 equal charges. ಎಲ್ಲಾ ಕಾರ್ನರ್ ಅಲ್ಲೂ ಈಕ್ವಲ್ ಚಾರ್ಜ್ ಇದೆ, ಪ್ಲಸ್ Q and plus Q, and it's an equilateral triangle andre all sides are equal to a length of A. Okay, so force on any one charge ಬೇಕು, so I'll choose this charge. Okay, let me say this as my A, B and C, and at the C ಯಾವ charge ಇದೆ ಅದರ ಮೇಲಿನ force ಬೇಕು ನಮಗೆ. Okay, so let us assume like that. So force on C due to the charge at A ಏನಾಗಿರುತ್ತೆ, so this will be repulsive in nature, so I'll call this as F1, and force at C due to the charge at B, again ಎರಡು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ರಿಪೆಲ್ ಆಗುತ್ತೆ. ರಿಪೆಲ್ ಅಂದ್ರೆ ಏನು, this charge will try to move away from the charge at B ಆಗಿರುತ್ತೆ, so this will be F2, and this is going to be equal to 60 degree. So because equilateral triangle, so ಎಲ್ಲ angle will be equal to 60 degree ಆಗಿರುತ್ತೆ. ಸೊ ಇದು 60 ಡಿಗ್ರಿನೇ ಆಗಿರುತ್ತೆ, ಆಗ ಇದು ವರ್ಟಿಕಲಿ ಅಪೋಸಿಟ್ ಆಂಗಲ್, ಸೊ ದ್ಯಾಟ್ ವಿಲ್ ಆಲ್ಸೋ ಬಿ ಈಕ್ವಲ್ ಟು 60 ಡಿಗ್ರಿ. ಸೊ ಆಂಗಲ್ ಬಿಟ್ವೀನ್ F1 F2 ಎಷ್ಟಾಗುತ್ತೆ, 60 ಡಿಗ್ರೀಸ್ ಆಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ ಈಗ ನೆಟ್ ಫೋರ್ಸ್ ಬೇಕು ನಮಗೆ. ಅದಕ್ಕೂ ಮುಂಚೆ ಫಸ್ಟ್ F1 ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಬರೆದ್ರೆ, ಓಕೆ, ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ F1 ಹೆಂಗ್ ಬರಿಬಹುದು, ದಟ್ ಈಸ್ ದಿ ಫೋರ್ಸ್ ಡ್ಯೂ ಟು ಚಾರ್ಜ್ ಅಟ್ A ಅಂಡ್ ಚಾರ್ಜ್ ಅಟ್ C, ರೈಟ್? ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ ದಿ ಚಾರ್ಜಸ್ which are placed at A and C ಏನಾಗಿರುತ್ತೆ, 1 by 4 pi epsilon naught Q into Q by A square ಆಗುತ್ತೆ, or I can say F1 is equals to, so ಇಲ್ಲಿ ಏನಿದೆ K ಅಂತ ನೋಟೇಷನ್ ಇದೆ, ಇಲ್ಲಿ K ಅಂದ್ರೆ 1 by 4 pi epsilon naught. ಯೂಶಲಿ ಅದು ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲೇ ಮೆನ್ಷನ್ ಮಾಡಿರ್ತಾರೆ, so I just take this as K itself, so K Q square by A square ಆಗುತ್ತೆ. Similarly F2 ವ್ಯಾಲ್ಯೂನು ಅದೇ ಬರುತ್ತೆ, ಹೋಪ್ ಯು ವಿಲ್ ಅಗ್ರಿ, KQ ಸ್ಕ್ವೇರ್ ಬೈ A ಸ್ಕ್ವೇರ್ ಬರುತ್ತೆ, ಬಿಕಾಸ್ ಅಲ್ಲಿಯ ಎರಡು ಚಾರ್ಜು Q ಅಂಡ್ Qನೇ ಇರೋದು, ಡಿಸ್ಟೆನ್ಸ್ ಏನೇ ಇರೋದ್ರಿಂದ KQ ಸ್ಕ್ವೇರ್ ಬೈ A ಸ್ಕ್ವೇರ್ ಆಗುತ್ತೆ. Now we want the net force. How do you find the net force? Yes, if you are there, please interact. Okay, so F net will be equal to square root of F1 square plus f2 square plus 2f1 f2 cos theta. ಇಲ್ಲಿ theta ಅಂದ್ರೆ ಎಷ್ಟು 60 degree. ಇದು ಗೊತ್ತಿರಬೇಕು. where theta is the angle between f1 and f2. ಓಕೆ, ಈಗ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. f net is equals to, so ಏನಾಗುತ್ತೆ square root of what I will do is, see here, as f1 and f2 magnitude same ಇದೆ ಅಲ್ಲ, so let us put that as something like f itself. Okay, or f1 ಅಂತಾನೆ ಬರ್ಕೊಂಡ್ಬೋದಲ್ವಾ. so f1 square plus f1 square 2f1 square ಆಗುತ್ತೆ, because f1 magnitude is equals to f2 ಇರೋದ್ರಿಂದ I'm just replacing wherever f2 is there, I'm just replacing by f1. okay, into cos 60 value ಎಷ್ಟು, cos 60 is half. okay, so I'll write here cos 60 degree is equals to 1 by 2. ಇದೊಂದು ಗೊತ್ತಿರಬೇಕು ನಿಮಗೆ. all trigonometric standard angle values you should know. okay, or ಇದನ್ನ simplify ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ, square root of, so here if you observe this 2 and this 2 will cancel out. ಏನು ಬರುತ್ತೆ ನಮಗೆ, yeah, f1 square plus f1 square plus f1 square ಅಂದ್ರೆ root 3 f1 square. hope you agree. root 3 f1 square, or this is nothing but root 3 f1 ಅಂತ ಬರೀಬಹುದು. ಕರೆಕ್ಟ್, root 3 times of f1 square ಇದೆ, square root ನ ತೆಗಿಬೋದಲ್ವಾ. f1 square, if it comes out of the root, you will get f1 itself. or this is like root 3 times of f1 ಅಂದ್ರೆ ಏನು ಬಂದಿದೆ ವ್ಯಾಲ್ಯೂ, kq square by a square. okay, root 3 kq square by a square. so that is option 4 is the correct answer. hope you are following. Any doubts? yeah, any doubts? yeah, so I think the next problem I had to give you some theory part of it. okay, yeah, so that equilibrium part I should discuss, and then I can come back to those problems. so what we will do is, we will wind up the session for now, for today. so in the next class I will continue with whatever that electric field cases are there, no. so these 2-3 cases and this equilibrium concept I had to discuss. so I had to tell you, like, apart from these two equilibrium also, there's one more specific case where 3 collinear charges are in equilibrium and 3 charge system is in equilibrium. so there is slight difference there. Along with the problems I would like to explain, it takes little more time, so that I'll just start that in the next session. okay, is that fine? This problem you can take it as a homework. Try solving. If not, anyway I'm going to discuss in the next session. okay, so ಇದು ಸೂಪರ್ಪೊಸಿಷನ್ ಪ್ರಿನ್ಸಿಪಲ್ ಮೇಲೆ ಬೇಸ್ಡ್. ಇಲ್ಲಿ ಹೆಂಗೀಗ ಟ್ರಯಾಂಗಲ್ ಗೆ ಮಾಡಿದೀವಲ್ಲ, ಅದೇ ತರ ಅಲ್ಲೇನಾಗಿದೆ ಹೆಕ್ಸಾಗಾನಲ್ ಅಲ್ಲಿ ಇದೆ. ಸೊ ಸ್ಲೈಟ್ ಡಿಫರೆನ್ಸ್ ಇದೆ. ಇಫ್ ಯು ಅಬ್ಸರ್ವ್ ಯಾವ್ಯಾವ ಫೋರ್ಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ ಅಂತ ನಿಮ್ಗೆ ಐಡೆಂಟಿಫೈ ಮಾಡಿದ್ರೆ ಇದು ಸಾಲ್ವ್ ಮಾಡೋದು ತುಂಬಾ ಈಸಿ ಇದೆ. okay, hope you try it. if not, we can discuss in next class as well. okay, so herewith we can end the session for the day. Before that, I just want you to remind you to register yourself for MVSAT. okay, so you can get the registration link in the description box of all the classes that are going now in live. okay, you will find there. Please register yourself. Please take up MVSAT, that is Mega Vedantu Scholarship Admission Test, and please remember the dates. so what are the dates? 4th, 5th, 11th and 12th of October. you have enough time for your preparation as well, and then you can get it might be a scholarship, you may get laptop or gadgets for your online study purpose. You can get a cash prize. okay, you can get scholarship, and you may get free online courses depending on the score that you are going to get. Okay, hope you will make the best use of it. Please do register yourself today itself, and exam centers will be our offline center, which is at JP Nagar. Okay, so if you have no doubts for today, I'm just going to end the session here. Thank you all. Have a good day ahead.